Yo, what's good, chat? What up, Fear? What up, Abstack, ABZ? I'm just gonna call you Abs. What's good, everyone? Scary, Shard, Arland. What's good? So Friday streams, I'm doing well. Friday streams, we're not gonna do boxes. We're gonna be doing like more, what's the term for it? More learning than practice. Boxes are great for they're great for learning as well, but they're mainly for practice, and reinforcing the skills you've learned. But we're gonna be learning a almost completely new topic to me. Not completely new, but I have little experience with binary exploitation. So that's what we're doing today. I was working on intro to assembly, but I just realized that that's a tier 2 module and I can't stream that. I can only stream tier 0 modules. Pebble in assembly before GTA 6. That's so funny. What up, Curio? Kachara. So, we can stream tier 0 modules. That's allowed in Tag the Box's terms of service. So we're just gonna get going. I mean, I've done it before, long ass time ago. I forgot how to do it, but I understand the concept. Buffer overflows are becoming less and less common because of memory safe languages. Like Rust is the biggest example. But in memory unsafe languages like C, C++, if you're not doing memory management securely, you have opportunities for buffer overflows, which is what we're gonna get into today. Dude, it is the affiliate anniversary. That's crazy. What up, Sponge? Today, was it 1 year ago exactly? Yeah, I think it was. Exactly a year ago, we got affiliate on Twitch. That's crazy. All right, buffer overflows. We're just chat. This is not gonna be the most entertaining stream. I don't know. Maybe you guys get some enjoyment out of this, but we're gonna be doing a lot of reading. That's all it is. Reading, research, and then we'll do a little bit of hands-on activities. But it's gonna be much more less hands-on than what we've been doing before. Buffer overflows, okay, literally exactly what I said, have become less common as modern compilers have built in. Yep, the compilers have protections as well that make it difficult for memory corruption bugs to occur accidentally. That being said, languages like C are not going away anytime soon, and they're predominant in embedded software and IoT. Who made this? Who's a Cryolite? Okay. Oh, gotta unlock it again. Module already unlocked. Okay, hack the box. A little bit of a bug there. It's all right though. Heap-based buffer overflow in sudo, and that was only 4 years ago. 2021. Maybe we'll take a look at this at the end. What up, Flick? What up, Tanny? Scheduled OCP for September after grind boxes now. Awesome. Hey, good luck. Good luck, dude. Hopefully I'll get my OSCP video out by then. The attacks aren't just limited to binaries. Buffer overflows have occurred in web apps and embedded devices which utilize custom web servers. My music's a little too loud for my liking. There we go. It's still a little loud. It might just be this particular song. Okay, another example. Whatever. In short, buffer overflows are caused by incorrect program code, which cannot process too large amounts of data correctly by the CPU and therefore manipulate the CPU's processing. Suppose too much data is written to a reserved memory, buffer or stack, that is not limited, for example. In that case, specific registers can be overwritten, which may allow code to be executed. You completed PWK and whole CPTS, so that is a big plus. I mean, I would definitely check out Proving Grounds because that's just the style of their boxes, but you sound like, I mean, you have all the skills needed, really. It's just more, you have all the skills. It's just learning how they like to make their boxes. So you spend less time down rabbit holes. I think that's the biggest thing to worry about. I know absolutely nothing about what we're doing. Me neither. Me neither. We're learning it right now. Where are you going to start? In terms of what? Just offensive security, hacking in general. Hack the Box Academy is great. Hack the Box Labs, Hack the Box Academy. Try Hack Me is also a good resource. This is a free module, so everything here, you can follow along if you want. This is completely free. They have, in terms of the Hack the Box Labs, they have a learning point, which has 3 tiers of machines that each tier increases in difficulty. But the way to get started is just by starting. Hands on the keyboard. Don't start with binary exploitation. I know people that started with that. I know people that only know binary exploitation. That's all they know. But just look around, do some research, pick what you want to start, and start. Justin, thanks for the follow. There we go. Curio only started with Pwn and only knows Pwn. Modern compilers have some stuff that moves stacks around to make memory less predictable, which increases complexity but still possible. Even memory-safe languages can have unsafe calls. Okay, well, we'll get there in the future. Yep, okay. Buffer overflows cause the program to crash, corrupt data, or harm structures in the program's runtime. The last of these can overwrite the specific program's return address with arbitrary data, allowing the attacker to execute commands with the privileges of the process vulnerable to the buffer overflow by passing arbitrary machine code. This code is usually intended to give us a more convenient access to the system to use it for our own purpose. Okay. I don't want to read all of this. Okay. We get it. Did I learn crypto? What do you mean, did I learn crypto? I understand cryptography, like the basics of it, but I'm not a math genius. Exploit development introduction. Exploit development comes in the exploitation phase after specific software units versions have been identified. Blah, 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 blah. The goal is to use information found in its analysis to exploit potential ways to gain interaction or access to the target system. Developing our own exploits can be complex and require deep understanding of CPU operations and the software's functions that serve our target. Many exploits are written in different programming languages. Most popular is Python. Fundamental understanding before developing. Okay, we know 0 days, end days. We know. All right, this is just vocabulary. We already know that. Maybe they mean cryptocurrency. I don't. Yeah, that's true. They could. What does that mean? Do I learn cryptocurrency? Like learn trading? Like learn blockchain? I mean, it's so broad. Architecture of von Neumann was developed by the Hungarian mathematician John von Neumann. Nice name there. Consists of 4 functional units: memory, control unit, arithmetical, that's a word, logical unit, and I/O unit. If you want to see mind trip and cryptography, go read on how zero knowledge proofs work. Dude, no, cryptography is like actually brain fuck to me. Like even something as simple as public key encryption is just fucking mind blowing to me. It's all math at the end of the day, but it's like I'm pretty good with math, but I'm not that level. Like you gotta be like actually like studying math, like above calculus. Like you gotta know your shit. What is 0 day? Yeah, okay, that's fine. So 0 day is an exploit found where nobody knows about it. Like only you know about it. It has yet to been exploited. It's 0 day because organizations have 0 days to patch it because they don't even know it exists. I'll read their definition of it. Exploits a newly identified vulnerability. The vulnerability does not need to be public in the application. The danger is that the devs don't even know it exists. So they will persist with new updates and shit. Enur? How's everything going? It's going well, going well. It's pronounced Neumann? Ew. That's gross. Hungarian style. Okay, well, if I want to be... Thank you, Minestress. If I want to be with the accent of the Hungarians, then sure. I'm going to say Newman. Screw you. Yeah, we just read that. CPU is responsible for executing instructions and for flow control. The instructions are executed one after the other, step by step. The connection between the processor, memory, input-output unit is called a bus system. Mind Asterisk with the prime sub. Appreciate you. Let's get it, let's go. Hell yeah. It really is. Does everyone say Neumann? Alright, fine. Alright, if everyone says it, then I'll say Neumann. Yeah, crypto's hard, dude. Memory can be divided into primary and secondary memory. Primary is the cache and RAM. Think about it logically. Memory is nothing more than a place to store information. You can think of it as leaving something at one of our friends to pick it up later. But for this, it's necessary to know where the friend's address is and what we've left behind. RAM can be accessed through their memory address. Cache is integrated into the processor and serves as a buffer, which in best case ensures that the processor is always fed with data and program code. Before the program code and data enter the processor for processing, the RAM serves as data storage. So cache is just right in the CPU. It's faster to access, and then RAM is a little bit slower to access. And then the slowest is obviously on disk in your hard drive. Do I know C++? I know it exists, yes. Do I use it often? No, not at all. This is my first time working with binary exploitation. Not my first time, but first time in a long time. So, take with that what you will. Secondary memory is the external data storage. Okay, that's what I'm talking about. Hard drives, CD. Not directly accessed by the CPU, but via I/O interfaces. In other words, mass storage device used for data does not need to be processed at the moment. Yada yada. Control unit. All right, this is responsible for the correct interworking of the processor's individual parts. The internal bus connection is used for the tasks of the CU, which is summarized by reading data from RAM, saving data in RAM, provide, decode, and execute an instruction. Processing the inputs from the peripheral devices and outputs. Interrupt, control, and monitor. Okay, the entire system. Okay, so this is your shit, dude. CU contains the instruction register. This is the important one. This is the big one. This is gonna be coming later for buffer overflows, which contains all instructions that the processor decodes and executes accordingly. The instruction decoder translates instructions and passes them into the execution unit, which then executes the instruction. The execution unit transfers the data to the ALU, the arithmetical logic unit, for calculation and receives the result from back from there. The data used during execution is temporarily stored in registers. Hey Pebbles, I like your stream. Thank you, Midnight. For this topic, I recommend learning C first. Yes, I've heard that as well, to learn C before C++. Because it's basically the same thing, but it's a little bit more obfuscated. C is like, you know exactly what's going on in the CPU at all times, basically, from what I've heard. Have I ever considered creating videos on YouTube to teach people about pen testing and CTFs? I literally have. Not much, but I want to get back into it. Dude, like, what do I even make shorts on? Like, there's nothing to do with shorts. Like, I don't know. Maybe I just post slop. Like, what, like, learning this stuff, like, it takes an entire video. Like, even just an overview of buffer overflows would take at least, like, 15 minutes. Like, I can't even do a short on anything. Like, I don't know. Unless it's just, like, funny clips and shit. Like, I don't know what else I would do. Alright, CPU. Functional unit in a computer that provides actual processing power, responsible for processing information, controlling the processing operations. The CPU fetches commands from memory, one after the other, and initiates data processing. Processor is also referred as the microprocessor when placed in a single electronic circuit. CPU architecture, yep. Each of the CPU architecture is built in a specific way. Therefore, describes the behavior of the CPU, how it receives instructions, yada yada. I know that. I need to learn low-level programming. Is it true that with this language you can control absolutely everything? Like where to put data on the stack, for example? Or putting data in any register? I believe so. Do you get absolute control of the machine? Yes. I believe so. I mean, it's literally just... I mean, it ends up, like, when it's compiled, I guess you can kind of control how the compiler works, but then at that point, it's more of a compiler problem. Like, if you really just want to be... You could just... If you want to be direct, you just code an assembly. And then, like, just raw compile it. But I think C is probably like the lowest language that people genuinely use. What does the clone sys call? I can't type. Huh. Is Docker shit? Interesting. Okay. Get risk for 3264-bit. Just different. What are these? Your ISAs. Instruction set architecture. All right, the cycle. You fetch memory. Instructions. Decode it. Operands. If further data have been loaded into execution, these are loaded from the cache or RAM into the working registers. All right, then you execute it, and then you update the instruction pointer to the next instruction. All right, now we get to the fun stuff. Buffer overflow. Yep, only works in low abstract languages, memory unsafe. Compiled almost directly to machine code. Portable executables, ELFs, we know that. Binaries in Microsoft, Unix. Okay. The instructions are used to model the program flow. The return addresses are stored in memory, which refers to the memory address and thus define the program's control flow. If such a return address is deliberately overwritten using a buffer overflow, the attacker can manipulate the program by having the return address refer to another function or subroutine. It would also be possible to jump back into a code previously introduced by user input. To understand how it works on the technical level, we need to understand how the memory is divided and used, how the debugger displays names and individual instructions, and how it can be used to detect the vulnerabilities, and how we can manipulate the memory. Rebuild and configure the target system. Wait, what? Most of the time, we'll only have one attempt to exploit the program if we miss the opportunity to restart. Oh yeah, because it just This is why you almost rarely do buffer. You basically never do kernel exploits, buffer overflow shit in client environments if you're doing an actual like a pen test network assessment. It's just shit could go wrong and it can just fuck stuff up really badly. Okay. Memory. When the program's called, the sections are mapped to the segments in the process, and the segments are loaded into memory as described by the ELF file, which is just your standard like Linux binary format. Forget executable linking format. That's what it's called. So this is your buffer. This is your memory. So the text section contains the assembler instructions. This area can be read-only to prevent the process from accidentally modifying its own instructions. Any attempt to write to this will result in a segmentation fault. Data contains the variables. And BSS. What is that? Contains statically allocated variables, represented exclusively by 0 bits. What? Okay. What's the difference between BSS and data? Oh, as part of the data segment. Okay, I'm not gonna worry too much about that. Heap memory is allocated from this area. This area starts at the end of BSS and grows to the higher memory addresses. So here's your lowest memory address, here's your highest, and the data is filled up as so from bottom to top. That's why it's called this. This is why this is called a stack, because it just stacks. Yes, there you go. Last in, first out. So it's like if you stack pancakes, you take the pancake off the top. The last one in is the first one out. Can I suggest you an ethical hacking roadmap? Do some research, pick something that's interesting, and learn about it. That's your roadmap. Please don't blame me, newbie, web guy. The binary exploitation and pwn is something which I always avoided. Can I explain what the career opportunities in this are? I mean, you can do just... You could you can do just as you do like web app assessments. You can do the same with like binary exploitation. It's just extremely less common. And you could do like independent. You don't have to work. You can just do independent shit. Like you could find a buffer overflow in fucking Discord and make a substantial amount of money from it. Ethically and unethically. Obviously, I suggest the ethical route. BSS contains uninitialized variables, both static and global. Oh, okay, got you. What up, Halsuggen? The stack is defined in an area. Okay, hold on. Just stack is return addresses, parameters, depending on compiler options, frame pointers. C local variables are stored here. You can even copy code to stack. The stack is defined is a defined area in RAM. The linker reserves this area. Contents are accessed via the stack pointer. To set up the upper end of the stack during initialization. And it grows down to lower addresses. So it starts at the max memory address and then it just goes down. Like opposite to the heap. Modern memory protections, DEP and ASLR, would prevent the damage caused by buffer overflows. DEP, or data execution prevention, marked regions of memory read-only. Read-only memory region is where some user input is stored, such as the stack. So the idea is that, okay, it just prevents overwriting it from uploading shellcode and then setting the instruction pointer to the shellcode. Makes sense. And then what is... Hackers started using ROP, return-oriented programming, to get around this, as it allowed them to upload shellcode to an executable space and then use existing calls to execute it. With ROP, the attacker needs to know the memory address of where things are stored, so the defense against it was to implement ASLR, address space layout randomization, which is what I think Tawny was talking about, which randomizes where everything is stored, making ROP more difficult. Users can get around ASLR by leaking memory addresses, but this makes exploits less reliable and sometimes impossible. For example, the free float FTP server is trivial exploit on Windows XP. However, if the application is ran on a modern Windows operating system, the buffer overflow exists, but is currently non-trivial due to EP, and ASLR, as there's no known way to leak the memory addresses. Currently building your own SSTI tool. Have any gripes with current SSTI tools like SSTI map? So I can make mine. I've never even used SSTI map. I don't really use automation with SSTI. So my answer is no. No specific gripes. All right, example of vulnerable program in C using a string copy. So strings are like, I think the most strings in C, C++, like the most notable cause, or like they're just so easy to do wrong. Because it's just a buffer of characters, like an array of characters. And if you just make the buffer I believe more than it should be, we'll get into that. We'll read. Yes, we just learned ASLR, modern operating systems to protect it. Oh, okay, so we're gonna run this. We're gonna run this. Oops, I just closed it. Fuck me. There we go. All right, we'll take this C code. Oh, I gotta make a little thing for this. So you hack the lock. Do I have Academy? I think I do. Yeah, I do. All right, make their Linux buffer overflow. And then bow.c. Okay, so we're gonna compile this and disable ASLR. Randomize. Okay, so we're. What does this look like? It's just one? It's two. Okay. So we're gonna make this 0, which is gonna disable ASLR, which is randomizing the addresses and shit. We're gonna have to run that sudo. Oh, I have to be root to do that. I can't even do it with sudo. They want that locked down. Too bad. Damn. Okay. And now it should be 0. And then compile it. Sure you have GCC. I can go down. I did not compile. No such file directory. Maybe I... Oh, I don't have multi-lid. That's probably... Okay, there we go. Gotta get all the libraries. And again, with these streams, I'm learning a lot. So, probably not going to be able to answer as many questions as I would like on this stuff. But ask me questions about networks, web apps, etc. I'll be happy to answer. Okay, can we compile now? Indeed we can. F no stack protector. Okay, so this is just making it as insecure as possible without all the protections that modern compilers use. If you just file it, we see it's an ELF 32-bit executable. And if we run it, doesn't work. We get a segmentation fault. Okay, maybe that's intended. I don't know. We'll see. There are several vulnerable functions in C that do not independently protect the memory. Scanf, string copy, string cat, sprintf gets. Okay. And GDB introductions. I need to pass an argument. I didn't even read it. Let's read the code. Yes. It just prints whatever I put as argument. So if I put Dookie in here, it'll print Dookie. No? Oh, it just prints done. It doesn't. What is bowfunk? Bowfunk. Oh, it just copies the string to the buffer. Interesting. Okay, it doesn't. Okay. So it just copies whatever I put in here in this buffer. We're gonna get to the exploitation part later. GDB is the GNU debugger. We've used that before. Used to view the binary on the assembler level. Okay, let's go ahead and do that. We're now at GDB. Hello, bro. No spam, please. No spam. Or else you're get the boot. This has main, I'm assuming. Yeah, they did. Alright, so disassembled the main function. And that's what we get. Oh boy. Okay. Oh, this is absolutely vomiting. Alright, first column is just the memory addresses. Numbers with the plus sign show the memory jumps. The address jumps in memory in bytes. Numbers with plus signs. These. Okay. +4, +7, +10. Okay, so that's just how much it increases. Next, we can see assembler instructions, and then their operative suffixes. Current syntax is AT&T, which is bad. We don't want NTT, we want Intel. You can recognize this by % and $sign characters. I don't see % and $sign characters. I think I'm in Intel. Yeah, I'm definitely in Intel. I think I have GDB set to Intel already. Memory jump is a weird way to describe it. It's the relative distance from my current line. Yeah. Yeah, I understood that. I understood it. This is the current line because it's +0. And this is for what? Four bytes away? I assume. What of 0? Yeah, for like, yeah, it's just +4. Yeah, I'm already in Intel, so we're fine. My disassembly flavor is already Intel. Yeah, I already have that set. Difference between AT&T and Intel syntax is the order and direction they're executed. Intel has a destination before the source. Okay. Which address is the main function called? I believe. Well, this is the main function, so we gotta find what main is called. So info functions. Fuck, I gotta run ads. We'll do this right after ads. So sad. What's this course? What are we learning? We're learning binary exploitation, 32-bit Linux binary exploitation on Hack-the-Box Academy. Oh, sorry, not buffer overflow. Stack-based buffer overflow on Linux, which is just a part of binary exploitation. Hack-the-Box has like nothing on binary exploitation in terms of Academy. We're gonna if we're gonna continue this in the future, we're gonna have to look at some more resources because I only have intro to assembly and then 32-bit binary exploitation in Linux and Windows, and you can go a lot farther than that. I know some other resources that are definitely more advanced. But it's only if we want to get back to this. I'd like to spend a day learning binary exploitation. At least just like simple buffer overflows. Just good knowledge to have. I feel like Fridays will be good for Portswigger. And what else should we do on Fridays? If we have time after this, maybe we'll do a challenge. Yeah, that'd be a cool idea. We do a challenge. Just to reinforce. But Fridays, I'll probably be doing Portswigger and shit. I'm gonna take CRTO. Probably, I'm gonna start it next week if I have time. I think I can start it next week. I obviously can't stream that. I'd love to, but I can't stream that. Hack the box, hack the box. Yes, we are on hack the box. Okay, we're back here. All right, which address is the main function called? All right, info functions. So this is the main function. So when is this called in bofunc? So you have to disass the bofunc function. That's not bofunc. I'm gonna start working. Yeah, I'd hope so. I'd hope I can. No, but it's actually going pretty well. Is that bash? This is a bash terminal. We are in GDB right now. That's what he means. But yeah, jobs are looking good. Yes, I have been actively applying. It's just been slowly improving every week. So, binary exploitation on developer. I don't know if it was necessarily binary exploitation. I think it was more so. I think if I remember that one, it was more just reversing. But I watched IPSEC's video on it, and that was helpful. But I mean, we looked at how to finish it, but we didn't finish ourselves. Maybe we'll go back to that if we ever do it a day on just reversing. Might be something to look into. But we ended up using a write-up to finish it, I believe. Or maybe, no, I don't know if he did finish it. Try to remember exactly. So it's a little bit ago. Interviews are going well. I use VMware, slow, VirtualBox is fast. It's probably something with your settings. I mean, VirtualBox I think is better on Linux, and VMware is better on Windows hosts. But it's... Why are there a target here? I'm not sure. Oh, they want us to SSH in here. They want us to SSH into here and do it on that binary. It's probably the same binary, though, no? We'll see. So here's bofunc. So when does it call main? Oh, no. Is it main call bofunc? I think I read it wrong. Yeah, it's main call bofunc here at this memory address. I didn't read that. How is that incorrect? What is it? How does it want it formatted? Like this? What exactly are we doing? We are learning buffer overflows. We have disassembled a binary. I mean, it's hard to do you even know like what a binary is? It's an executable file. We've disassembled it, meaning we can see every like machine code, every instruction at the machine code level, like what the CPU is actually doing. And we're just working through some labs to understand some exploitation. Yeah, okay. We have to SSH in. Okay. Yo, man. What up, Nima? Gotta wait for it to spawn. We're gonna have to, connect to the VPN. You look like that tennis player. that tennis player. Was it Frederick Roderer or something? How do you find exploits? That's what this entire channel is all about. The OS assigns a memory address? Yeah, maybe. Ben Shelton. Who's this guy, bro? I look like this guy? Alright, thanks. That's a compliment. I'll take that. Yes, say something. Here's kind of messed up. It is kind of close. I'm not gonna lie. I kind of do look a little bit like them. It's not wrong. We have there it is. All right. So do you have GDB? I'm assuming on bow. Oh, it's in Intel. Actually, doesn't matter at the moment. This is just a callable func. This is the memory address. We good? We good. Hooray! Where am I? Oh, that's someone else. Belly, thank you. Can you tell us what we've worked through today? Not much. We've just been working on stack-based buffer overflows on Linux. Okay, anyways. Next part. Good luck, Ben. Thanks, Nemo. Alright, the registers. Essential component of a CPU. All registers offer a small amount of storage space where data can be temporarily stored. The most critical registers we need are general registers. In these, there are further subdivisions, data registers, pointer registers, and index registers. EAX and REX are accumulator registers. Accumulator is used in I/O for arithmetic operations. Okay, I don't think we don't need to know like the specific descriptions of each register. The pointer registers are the ones we really want to look at for this case. I'm gonna guess EIP, which is the instruction pointer. So this register says where the next instruction is going to be executed. So if we can modify this, or if we can like read this and then change where it's pointing to, or if it's like change what is at the address that it's pointing to, then big problems there. Knowing what they're used for is definitely useful. I feel like if I come across it and I need to know, then I'll read this, but like... Okay, this is for like looping stuff. The C stuff. And the D is data used for I/O. For multiplying and division. For large values. EBP is a stack base pointer. Points to the base of the stack. And then ESP points to the top of the stack. Okie dokie. Frames. Since the stack starts with the high address and grows down to the lower memory addresses, the base pointer points to the beginning. Right, because that constantly changes. Contrast to the stack pointer, which points to the top of the stack. Stack pointer, base pointer. As the stack grows, it is logically divided into regions called stack frames, which allocate the required memory in the stack for the corresponding function. A stack frame defines a frame of data with the beginning and end that is pushed onto a stack where the function is called. Since stack is last in, first out, the first step is to store the previous EBP, the base pointer, on the stack. Right, because you gotta go bottom up. Which can be restored after the function completes. If you look at bofunc, it looks like this in GDB. Stores previous EBP. Okay. The EBP in the stack frame is set first when the function is called and contains the EBP of the previous stack frame. Next, the value of ESP is copied to the EBP, creating a new stack frame. Push EBP stores the previous EBP, and then move ESP to EBP? Is it right moves to left, I assume? Or the way around. EBP equals ESP. Okay, that makes sense. So yeah, right is going to be now equal to the left. So you need to understand full assembly in order to understand buffer overflow. You should be able to understand some assembly, yeah. I think. You can read Chinese. No. Chinese is not a language. What academy subscription do I have? At the moment, none. At the moment, none. I canceled mine, but I had student. Because I did CPTS and CBBH, which is all covered under student subscription. But at the moment, I don't have any. Because I don't need to. Because I'm not doing any more academy modules. Index registers. Source index. Pointer for source for string operations. Okay, this is gonna get important. The source and destination for strings. We're doing binary today, Shyhat. Yes, sir. So I just buy boxes? What do you mean I buy boxes? Oh, you mean like the currency? No, I don't use Academy anymore at the moment. Well, like the paid stuff. To answer your question. But yes, I have like, from doing that, I have like almost 800 cubes, is what you mean. From doing the courses. Another important point concerning the representation of the assembler is the naming of the registers. Depends on the format that the binary is compiled. We've used GCC to compile it, so now they're going to change it to 64-bit. So again, the name of the register is changed based on the architecture. Yeah, it's all changed now to R instead of E for most of it. And the addresses are twice as big. The most important function right now is the call to the bow function. The call instruction is used to call a function and performs two operations. It pushes the return address onto the stack so that the execution of the program can be continued after the function has successfully fulfilled its goal. Pushes the return address onto the stack. Okay, that makes sense. It changes the instruction pointer to the call the next to the call destination. Gotcha. That makes sense. Okay. Have I done a lot of buffer overflow stuff in the past? Not a lot. I've done it in the past, but that was a long time ago. So this is like a full refresh, and I'm learning even more now. Endianness, I know this. The byte order, left to right, right to left, whatever. I honestly forget which one's which. Big endian, digits with the highest valence or at the start. And then little endian, the lowest are at the start. So little is left to right. Alright, take control of the EIP. Here we go. Now we get to the fun stuff. The most important aspect of a stack-based buffer overflow is to get the EIP under control, so we can tell it which address to it should jump. So again, this is the instruction pointer. This is the register that says, hey, we're going to execute this next. This will make the EIP point to the address wherever our shellcode starts and cause the CPU to execute it. We can execute commands in GDB using Python, which serves us directly as input. Alright, so we just run Python in there. Cool. Oh, this is... Okay, so we just run... This is like an embedded command here. So this is just printing... What is this in ASCII? Whatever. This byte 1,200 times. And then it gets a segmentation fault. It's a U, okay. So 1,200 U's as input. You can see from register information that we've overwritten EIP. Gotcha. So this is our argument to it. Okay, so we'll take a look at this some more deeply. Let me go here. We have that. So again, we run it like this, or we like have two spots. So at the top, we'll read it. Let's actually do this. Okay, so that's our binary here. It takes an argument, and then it calls bofunc with our argument, which just takes the string and puts it to a buffer. What are the differences between PID and IC? Where do you see that? What do you mean PID and IC? I don't know what you're talking about. You mean like PID, like process identifier? I don't know exactly what you mean. Try BDB on this. So he's trolling me. Did I not load bow? Oh, bow 32. Hey bro, good afternoon. Hello, Henrique. What do you mean PID and instruction counter? What's PID besides process identifier? Sass main. So if we go info registers, there was no registers now. Okay, we need to run it first. So if I just regularly run it, and now I go info registers, EIP has this memory address. I don't know why it's showing twice, but it is. You meant EIP and not PID. Okay, that makes a lot more sense. Instruction counter. Well, EIP is a pointer. Where do you see icy? It's not a reference here. They're the same thing, they're the same thing, it's fine. So then if we run this again, but we do the Python shit, we print this a bunch as the argument instead of just running. In this case, we ran it with nothing as the argument. Now we run it again. We do info registers. Did EIP change? So this ends in 738. And before we had 738. That did not change. Okay. We didn't even get a segmentation fault, did we? No, we did. It's because the Python failed. Missing parentheses in print. This is Python 2. That's why. This is using Python 2. There we go. Now info registers. EIP. And now it ends in 5s. Okay, good. Good. Alright, we overwrit EIP. Overwrote, I guess is correct grammar. EBP and EIP have been overwritten. Sweet. Alright, so this is an image to view what we did visually. So it uses string copy. Was that the function? Yeah, it does. String copy. Copy the string to the buffer. But it's much bigger than the allocated space. So it gets overwritten the EIP and overwrites EIP and EBP. Sideways stack. Yeah, this is bad. You're right. Sideways stack. It's much easier to make it vertical, like pancake style, but yeah. Ugh. We have write access to EIP, in turn allowing us to specify which memory address we should jump to for execution. However, to manipulate the register, we need the exact number of views right up to it, so that the following 4 bytes can be overwritten to our desired memory address. Again, we want to set this to exactly what we want. If you do too many bytes, then we'll go too far. We want to be right before it so we can put what we want. Determining the offset. The offset is used to determine how many bytes are needed to overwrite the buffer and how much space we have around our shellcode. Shellcode is program code that contains instructions for an operation we want the CPU to perform. Yep, use Metasploit to create shellcode. That's fine. Metasploit offers a Ruby script called pattern create, which can help us determine the exact number of bytes to reach the EIP. It creates a unique string based on the length of bytes we specify to help determine the offset. Oh, that's great. That's great. That is great. That is super useful. That makes it a lot easier. All right, well, let me put that in my notes. Hey, what's up? My videos are lovely. New to the field, I learned C, basic syntax. I want to get deeper into maldev. I learned about process, threads, handles, etc. But after that, things got very hard and I don't know what to do. Don't just stop because it's hard. I mean, shit's hard. Yeah. I mean, what do you mean you don't know what to do? You keep going if you want to. That's what you do. You just keep going. Just because it's hard doesn't mean you should quit. If it's what you want to do. I have a question. Why shellcode in OX? And how is that string turned into instructions? Shouldn't be just a string for the CPU? What do you mean? All right, OX is just, I don't know why. It's just what it is for hex. It's just to represent hex, saying, okay, this is hex. But the string overwrote the instructions because the allocated space for the string was less than what it actually was. It only allocated what? This many bytes? And we did 1200 instead, I believe. All right, where's... I guess we'll go low level. We'll go buffer overflow. We'll go... we'll go this. We'll go finding offset. Let me get this in here. Thank you, Anton. Welcome, welcome. Okay, so let's go ahead and do that. I'm gonna close this. Okay, so pattern now just has a random pattern that's 1200 bytes long. So instead of just printing 1200 U's, we'll do that random pattern, and then we can find what's at EIP, and we'll determine the number of bytes we need to get there. Okay, so let's run. I shouldn't need to just print what I have. I should just be able to just copy it. So if I just cat pattern, let's put it into xclip -cell and just paste that in. That should be fine. For my notes, Pwn tools. Yeah, this is a Python library. I've seen this before. We're doing binary exploitation. Yeah, I've seen this. I'll put this in there. Am I allowed to show Xbox Academy like that? Yes, if it's tier 0. This is a tier 0 module. It's free, so I can't show it. Oh, fuck, I went too far. Offset. Okay. Info registers. We can specify the one. EAP. Okay, so now it's this, which is exactly what they have. You know, we did it right. And then we use pattern offset to calculate the number of characters we need to advance. Okay, cool. EAP register. Okay. I already got to use Pwn Tools? No. Versace just pointed it out as a useful library in the future. Okay, how'd CubeDoc go, Ryan? What'd you guys talk about there? Value, yeah, the value of it. Okay, alright, I'll write the value, just so I know it's not like the actual... Okay, that's fine. Okay. Should be good. And now we can see this is exactly the amount we want. So we want exactly 1,036 bytes, which will get us right up to EIP. And then the next 4 bytes will be EIP. So that'll be pointing to wherever we want to go. But before that, we're going to want to write some shellcode on the stack to execute. So we'll want to put like some whatever malicious code in here, and then we'll overwrite EAP to point to that instruction, that malicious instruction, and then we continue, it'll execute, we good. We talked about how easy binx is. Yeah, okay, I know that is not true at all. That's definitely not what you guys talked about. I'm assuming it had stuff to do with, I don't know, maybe the new Vuln Lab boxes and stuff. Also, is Vuln Lab only VIP plus because of cleanup scripts? And if so, kind of silly. Jobs, industry, miscellaneous shit. Okay. Okay. All right, offset. Okay, so now they're replacing what's 66. What letter is that? I don't know what fucking letter this is, bro. Is there a way to easily like in my terminal just go hex? I mean, without Python, like hex to string. I guess I could just do this, right? But that's just like so stupid. F. Okay. Vuln is VIP plus because XCT didn't build them with a shared environment in mind. And the way you have to build a box for a shared environment is wildly different than if you assume a dedicated instance. What are the differences besides cleanup scripts? Tell me about it. Coupled with my opinion, I believe there are 0 days in every software. Not every software. I don't know about every software. Yes, there are tons that are waiting to be discovered, yes, but I mean at some point, whether it's like a hardware issue, right? Like almost everything can be exploited. But like even modern day encryption, we're now having to develop quantum secure encryption methods because just like your regular encryption now can just be fucked by quantum computing. So is that a 0 day? Not necessarily, but what's a vulnerability? Echo to XXD. That's the tool I forgot about. XXD. There we go. That's the one. Are you allowed to read in Hackbox Academy modules? Only tier 0 modules. Only tier 0. Play this. What's to print in ASCII? Am I doing it wrong? No, I think it's just 66, isn't it? You want OX. Wait, how do I specify it to... F, there we go, that's it. There we go. Dash P will make it look nicer. That did not make it look nice at all. The dash P. Don't even say. Whatever. Prints it on the right here. Fine. Oh. Okay, so they're gonna overwrite it with just a bunch of Fs. I guess we can do that as a proof of concept. Dash R, reverse operation. I don't think so. Yeah, I don't know. I don't think so. I think that's to go to dump hex. Right? I don't know. It's fine. This works. You can find hard-coded credentials in XSD in a binary, true or not. Yeah, you can. You also do strings. I mean, which is essentially what XSD does, I guess. Just print strings. If you want to do it that way. Am I still studying, or I work these days? I'm still studying. I'll never stop studying. Okay, so now let's just overwrite EIP with 6s. Sure. So we got the offset we need, which was 1036. So now we go back to running this, but we'll only do our use up to 1036, and then we'll add Fs, which is 66, for 4 bytes, right to overwrite EIP. So now info registers, and EIP is now 6s, and we're all good to go. I mean, college. I'm not in a college now. Never was. Probably never will. We control EIP. We'll override it, pointing to shellcode. Cool. Examine the registers with the address of EIP. Ah, fucking gotta SSH this shit again. Is this the same? Okay, it's the same. So we can stick with this. We're gonna have to fucking. Do I not have? No, I don't. That's sad. Okay, let me put that. Let me get the command to go to Intel syntax in my notes. Here we go. Go Intel. Slyborg, you are not first, but welcome to the stream. I don't know how no one redeemed that. What a great live like this module. Thank you, thank you. Go do that. Oh, it did paste. All right, now we're in Intel. So this as main again. There we go. We have Intel syntax. Let's go back to the module we're working on. Taking control of the IP. No, we didn't do this one. Yeah, we didn't do the lab thingy for it. Examine the registers and submit the address of EVP. Okay. That's just EV info registers. We need to run it. EVP array. That was not much of a. Well, this is the address of EVP. Does it want me to do it? Actually, you know what? It wants me to do it after we did the exploit, which just gets overwritten with 5, so we didn't even need the SSH. Yeah, because, I mean, registers don't have... Well, such thing. Yeah. I mean, the other registers are going to be different, but we just overwrite them with what we put as user input anyways, so it ends up being the same. Alright, length of shellcode. It's easy enough. I mean, it just says it in our output of Metasploit. Or, yeah. This is a reverse shell. As a precaution, we should try to make a larger range if the shellcode increases due to later specifications. Okay. Interesting. It can often be useful to insert NOPs, no operation instructions, before a shellcode begins, so that can be executed cleanly. Huh. Okay, so we need our offset to get to EIP. After EIP, and then before that, within this offset, we want 100 bytes of NOPs. Why do we need NOPs? Does it just flush? Does it just like flush out? I don't know. Why do we need that? And then 150 for a shellcode. Basically a flush. Okay. But like, what is it flushing out though? That's what I was thinking that. Like, what is it flushing out? You know what I mean? Just instructions that haven't finished? Helps line it up nicely. Like, what does that mean at a low level, though? Line it up nicely. You know what I mean? I'd like to understand that. Because, like, from my knowledge, I mean, like, machine code is machine code, right? So, like, if I point to some place in memory to execute, it should just execute that. You know what I'm saying? Like, why do... Alright. I don't know. Maybe that's like a ChatGPT question. Actually, I don't know if it'll answer me. This is what comes before and after shellcode. That doesn't explain much. In terms of buffer overflow. Holmes. Why is this needed? Explain at a low level. I don't face back pain? Oh, I face back pain, brother. I got the back of an 80-year-old. It's so bad. It is really bad. The NOP sled. To deal with uncertainty. Like, bro, be more specific. Imprecise return addresses. Increases success rate without... Alright. Okay, so we can overshoot and undershoot it. And it'll still get executed, right? So, okay, it's like... That's a good example. That helps, okay? So it's like our runway. We can land anywhere on the runway, and eventually we're going to get to our shellcode that we want to execute. Gonna have to press the I believe button on that one. I don't think we need this. Like, seriously, I don't think we need this. I'm sure this makes sense, as it just gives us more room to work with, but I don't think we need this. We're going to try it. We're going to try both. We're going to try it. After we do this, we're going to try it with no NOPs and see if it still works. Be a real shame if my back pain until the next assassination of an insurance CEO. I don't know, man. Insurance sucks, dude. Chat, what's the solution to back pain in the IT industry? Does anyone know? Like, actually, does anyone know? Besides, like, having standing desks. Which, when I move out, I'm getting a standing desk. Like, one that has suspension and can stand up. A lazy boy. None. I mean, surely we gotta figure something out, right? Alright, we're cooked. My shellcode's in the EBP. We want that after. After the stack? Okay. ESP on in the heap. No, this is after the heap. Okay. Stretching in the gym. NOPS sled may not be needed because it's such a simple exploit in this case. Okay. So when you get to more complex stuff, it's just useful to have. Okay. Good to know. Gym. Get a bear chair and sit the right way. Facts. Maybe it's just so simple. The posture check's crazy there. Echo piped into XXD-R-P. Okay, there we go. Appreciate it. Dude, my monitors don't go up anymore though. So looking straight ahead is at the camera. Like straight ahead is at the camera. Maybe even a little bit above it. But my monitors don't go up anymore. I guess I can put my chair down, but I like to have my armrests like right in line with the table, so I'm not like angled or down or anything. I'm just straight. I don't know, man. When I move, I'll optimize it for ergonomics. All right, let's do this, chat. Let's get going. Let's make some shellcode. I guess we'll use this one. That's fine. All right. So this generates a Linux unstaged reverse shell at localhost at elite port. Nice. Linux elf executable 32-bit in C format. Here's our shellcode. So when this gets executed, it'll establish reverse shell. So where do we put that in Python? Oh, they're doing that later. They're not doing that right now. Okay. Right now they're just getting the format right. Okay. Oh, the buffer goes this way. Wait, am I tweaking? We going this way. For some reason, I thought we were going stack down. We're not. We're going up from the string copy. Okay. So everything needs to be before the EIP. I mean, I already knew that, but I thought we were going the other way. How large can a shellcode theoretically be before, if we count NOPs? theoretically become if we count NOPs and the shellcode together? How large can a shellcode become if we count NOPs and the shellcode size together? So that's if we have to have at a minimum 100 bytes of NOPs. So it'll be all right. So it's 1040 to reach EIP. Uh, 1040 to reach EIP, and then minus just 100 NOPs. I don't know why I'm doing this in Python. So then we have that many bytes in space for shellcode. 0 bytes. Oh, it wants it in that format. Okay, so how do I print in hex? Wait, yeah, I want that in bytes. Print hex Python. The shellcode is a damn string. I don't get why I could just transform it into instructions as a compiler. No, it's with the binary itself. I just killed that. Fuck. Whatever. I'll go back to it. So let's UM.c. It's because it's using this insecure function. It is a string as our argument. Well, it's not really even I mean, it's not even specifying it as a string. It's just a parameter name. But anyways, that, well, I guess it is because it's just a bunch of characters. Whatever. It gets put into the buffer, but which is it's just a space in memory. It's all it is. Like a string, it's just some ones and zeros in a space of memory. But what ends up happening is it's just greater than this. So we're going over the amount that it's specified for. So the string should be this amount, but it's a bit bigger. So now it gets turned into machine code. Other instructions. We overwrite shit. I've written exploits where I needed exactly 3 bytes of NOP to line stuff up this way. NOP sleds are just another important tool. Okay. Hello, this is Random. I'm a college student. Want to ask if it's worth it to pursue OffSec. Worth it to pursue. I've seen multiple videos and Reddit posts stating about bad conditions of entry-level jobs. Yes. All right, you want my opinion on this? I'll give you my opinion on this. This is how I feel. Because I was in a similar certain situation. I wasn't a college student, but I was in a very similar situation. I didn't even know the market was bad till I like tried applying. It's fucking rough, especially for entry-level positions. But I don't care. This is what I want to do with the rest of my life. I don't care. This is what I love. I do this every single day. So what if the job market sucks? I'm not gonna stop, and that's what's gonna help me stand out. And I know I'm gonna get a job because it's either I do or I die. And so what? If I die, then I won't care because I'm dead. So, I mean, this is what I do with my life. If you love it that much, if you just care about getting an easy job, offensive security is not for you. It is very competitive. And at the moment, a lot of people are getting laid off. A lot of people with a lot of skills and a lot of experience. So it is hard. We had 940. Print this in hex. It's just the hex function. All right, Python is so nice. So print, and then we go hex. 3AC. How's that wrong? if we count NOPs and shellcode size together. Oh, if we're counting that together. So it's just 1040. 410? No? What? If we're counting shellcode and NOPs together. I can't, this is worded weirdly. How large can our shellcode theoretically become if we count NOPs and the shellcode size together? I mean, the buffer has to be 1040. Oh, we have to subtract for the EIP as well. -4. I still think it's... I think it's this. I want to say it's this, because... I don't think that the NOP would be included in our answer. I think it says accounting for NOP, meaning we should subtract it. No? What? Format 00 bytes. God, this is kind of odd. Does it want a 0 in front of it? Bro, what the fuck? How does it want this formatted? Shellcode size together. How do you want this formatted? Gosh. Does it not want hex? Does it want just 1037? I'm kind of confused here. How you want this formatted? Come on, ActiveBox. Don't be like this. What are you asking? Hell yeah, Slideborg. Thanks for the 100 bits. Much appreciated. Why is this wrong? When I finish a box, will I ever figure out remediations and potentially fix the problem? Sometimes. Sometimes. Depends how I'm feeling. In my opinion, I mean, it depends on the box, right? I know most of the remediations for like just like SQL injection, for example. I mean, all right, take SQL injection on Microsoft SQL. The initial thing is just sanitization and fucking don't directly input user input into the SQL query, right? Parameterization, all that stuff. But then say we go to privileges, right? Like I can imply that. All right, so say we're given privileges for XPCMD shell, which is just from SQL directly to OS commands. It's just remove that privilege. Like I know what the remediation is without like really looking it up and having to do it myself. It's just remove the privilege, right? I mean, I could figure out like how to do that if I wanted to, but I mean, there's just really no point. I mean, I know that the solution is just remove the privilege. So I mean, it kind of depends, but most of the time, no. That's my answer. I want a binary you so bad. That was the worst thing I've ever heard in my life. That did not even make sense. Didn't even make sense. That was awful. Realm stupid. So why is this failing? Did Twitch chat die? I want to make sure Twitch chat didn't die. Oh, we're good. That's hot. It's not hot. Sorry. It's not. Gar's live! What the fuck? Damn, Gar's live. We're gonna have to raid Gar after this. Hopefully he's still live. Fuck, if he ends up raiding me, like, he's gonna end up raiding me like a half hour before I have to go. I know that for a fact. that's gonna happen. Hopefully not. I fear it will. Okay, whatever. Bro's never live. Okay, what is up with this question? What is up with this question? You know what? I'm just do this. I'm gonna just do this. And ChatGPT is gonna end up doing the same, giving me the same answer that I've put in, but because like this is just worded so poorly. Want to put my 1 in your 0? Okay, that one works, but that is crazy. That one works though. I suppose that one works. I saw you have an exploit notes tab. Can you what do you mean exploit notes tab? My notes? No, these are private notes. There's lots of notes in here. It's all private for many reasons. Just fucking answer the question, dude. For my low-level languages and cyber security class. Like, fuck you, dude. Just answer the question. Thank you. Thank you. What? Why are they subtracting? Where'd they get 786 from? This includes the shellcode, you goober. What the fuck are you talking about? It's not 250. I know that for a fact. This is just blatantly wrong. Yeah, ChatGPT, you fucking stupid ass. Alright. Dude, is it like it's not even like it's just like a wording of this question that's bad. If you do a pen test hire, try to add potential remediations to your notes. Yeah. I get that. Like, obviously, for reporting, I'm going to go in depth on remediation. Hi, bro. Hello. How large can our shellcode theoretically become if we count NOPs and the shellcode size together? Can it theoretically become if you count NOPs and the shellcode size together? Bro, what the fuck do you mean? It's definitely okay. So I don't know if we need text or not. So 1000 minus 4, or this minus 4, because this gets us to before EIP, and then it should just be that, honestly. If we're counting NOPs and shellcode together. What if we need to remove NOPs? Then it's minus 100. Did you change the vector in pen test? I don't know what you mean. Oh my gosh, it does have to include bytes in the answer. The word bytes. You're right. God damn it. Good looks there. Good looks. Good looks. Minus. Go back to here. This. What? 0. It did. We still gotta work with this, but it definitely has to include bytes in the answer. Is what it wants. Really? Or we want it in hex now? Do we still want it in hex, but then call it bytes? Oh, this is so weird. No, that would make sense. That would make sense. That would make sense. You mean byte exposition? We're just taking a look at it. It's good to be well-rounded sometimes. Get a little bit of fundamentals in other areas. Yeah, the wording's not the best. That's a known issue for a lot of the questions. I mean, it should be this, right? If we count NOP and the shellcode together. I mean, if like this is, if we're counting NOP and shellcode together, like we don't count NOPs. But if we're like including NOPs in our answer, then we need to subtract 100 for NOPs. Then we just use this. Why is that wrong? God. That's your entire buffer, not the whole shellcode. It's saying, well, yeah, it's saying the maximum length of the shellcode. The maximum shellcode size. So yeah, we'll essentially fill up the entire buffer with just shellcode. That's what it's asking. The maximum. Wait a second. NOPs plus shellcode is the number of NOPs and the shellcode generated. Yeah, I know that. Which would just be this minus 4. Because then you're left with this much for NOPs and shellcode. Are we not left with this much? I swear we are. Hello, sir. Cybersecurity is beginner friendly. If you're... I don't even know how to answer that question, dude. Short answer, no. Long answer, it depends. Get the size of that file, then add the NOPs. The size of the payload? But it's saying theoretically, how large can the shellcode be? It's not just our shellcode plus NOPs. It's saying how large can the shellcode be? That's how I interpret that. God, this is such a stupid question. Is it really just that? Is it just NOPs plus shellcode size? What is the size of the shellcode? Did we remove that? I think we removed it. But it was like 68, I think. 68 bytes. 68 plus 100, 168. I know that's not what they're asking. It's definitely not. God, this is such a stupid thing. Hello, sir, you spend years cybersecurity filled. What are you talking about? I'm sorry. Alright, I'm looking this up. Like, what the fuck is this? Not plus shellcode. 250. Where are you getting 250 from? NOPs is 100. Shellcode's... Oh, if this was in the example. Oh my gosh. This is so stupid. They didn't specify that they're using this specific example up here. And it doesn't even make sense. Alright, whatever. 250. This is the worst question ever. Whatever. What happened to my OCB exam? I got an 100. Perfect score. Terrible question. Very terrible question. Alright, finally next module. Identification of bad characters. There we go. Forgot about this one. So some characters are not gonna work. at the end of the day. Some bytes aren't gonna work. Reserved characters exist. They are not all the same. Bad characters, they're gonna happen. We can use a character list to find out all characters we have to consider to avoid putting in our shellcode. So they're putting that in there. And then how do we determine if it's bad or not? Look at the whole main function. If we execute it now, the program will crash. Oh, yeah, we have to do this. We have to like binary search to find which is the bad character. But we can just start it without these, because these are like generally you don't need these. I mean, they'll just make your shellcode longer the more you remove. But it's fine. Let's go, Sly! Hell yeah, what'd you win? W Slyborg, what'd you win? What was he doing in the marbles race? Dude, he does so many giveaways, it's crazy. Like, one of the last streams, like, he hasn't streamed in, like, ages, but he just, like, he must have done, like, 20 giveaways a stream on average when he used to stream a lot more consistently. Try hack me. So, yeah, hell yeah. Like, a month? 3 months? A year? What are we talking? What are we talking? The man's crazy. I think 2 months. Congratulations. Alright, so setting a breakpoint at the bowfunc functions. Am I gonna solve a binary exploitation box stream? Probably if we finish this, yeah. That'd be a good one to do. A little bit of reinforcement. Now we can execute the newly created input and look at the memory. Alright, they run this. And then after we execute the buffer with the bad characters, reach the breakpoint, we look at the stack. What is this? What is this GDB command? 2000 XB? The fuck is that? What is 2000 XB? Go to address? But go to this ESP plus 500? Like, why is it like this? Why doesn't it say go to? Why is it freaking goober shit? Why do I have to read it like this? I don't know. Kind of odd. I can just look it up. Okay. Subtracting. Okay, so they're doing it that way. They're reading memory. They're finding which ones don't exist, comparing it, and then they'll see which ones are bad. That's how they're doing it here. That one works. You know this character, remove it. Yada yada yada. Okay, so they're finding the breakpoint on each character. Yeah, so they do it again. 09 is gone. And they do it again. Or no, it's actually... Yeah, okay. You expect this instead of the 9, so yeah, that's gone. Okay. So, I guess it's handy to know how to do this, which I'll do. But in theory, you can just start your shellcode without these, because these are common to be bad. That is a command. X command is to examine memory. X is to examine, okay. Do I not have that in here? I need to put some more GDB info. If x/s. Okay, examining. I literally have notes on this. $2,000 is 2,000 units. B means unit size is byte, and X means in hex. Okay. Welcome to GDB. Appreciate it. Fully preparing for OSB, wanted to ask, what was the most difficult thing for you in passing the exam? One of the streams you said that in principle it's not difficult. Any advice? Yeah, it's not difficult at all. The hardest part is two things: avoiding rabbit holes and not overcomplicating shit. It's very simple. You just gotta know what not to do and know what to do, which is the hardest part. The hardest part is not exploitation. It's not some complex leak shit, anything like that. It is very simple, but you just gotta know which simple thing to do. And that just takes a lot of experience and a lot of practice, repetitions over and over and over again. I mean, it just helps doing a ton of boxes. Just do so many boxes that you know what's possible, you know what isn't possible, you know what to look for. And you do proving grounds, which is made by OffSec, and you start to understand, okay, they like to make their boxes this way. They may inch you this way into a rabbit hole, and you'll just catch on over time. I think it's just a lot of repetitions to get through that. And also review the course, because they're not going to put something on the exam that isn't in the course, right? So, like, for Windows Privilege as an example, you know, go through everything that they taught you in the course, because that's likely to be on there. It's not going to be some crazy thing that they wouldn't expect you to know. Any low-level stuff for OSB exam? No, not anymore. That was long ago. Okay, back to here. Okay, we're doing that. All right, we're finding bad characters. That's fine. Let's do that. So we're gonna have to make our shellcode again. Actually, it's fine. We have it right there. Awesome. Awesome sauce. Here's our shellcode. Okay. Let me do buffer overflow. Let me do 3 finding bad characters. So we'll go echo. Let's do this. Echo. Shellcode. And then they pipe that into here. Let's just go. Best example that we know what the format looks like. Shellcode equals /x 0/x 01, etc. Okay. This is for char's length. I get shellcode length. What am I doing? Get shellcode length. God, I hate this. Is kind of fun, so I gotta do this. This. I could probably change the formatting instead of doing it in C. This is probably a way to do raw bytes, but this is fine. Alright, our shellcode is 2 bytes. That is not correct. What the fuck? What? 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 How long did it take you to get through CPTS? A few months. And that was while I was in school. So, took a few months. I don't know exactly. Like 3-4 months. I don't know exactly. Why is it saying this is 2 bytes? It is not 2 bytes. I can guarantee you that. CR2 should be fun. Should be. I would stay motivated to do that every day. Motivation, isn't that something funny? I wouldn't want to do anything else. That's my answer. That's my answer. I wouldn't want to do anything else. Not sure why this is failing here. Shouldn't matter that this isn't single quotes or double quotes or whatever the fuck. Oops. Fuck. Do I go to the start? E? No. W? No. Fuck. A? There it is. Why is it saying it's 2 bytes? What is wrong with this? Hack the box is tweaking out. I don't get it. Consider changing main to links? No. There's software I need that's only compatible with Windows. Am I going crazy here? What's going on? Did Hackthebox just give a bad command? That doesn't work? I don't know said. Could be a useful Linux tool to learn for formatting stuff, but like I would assume they give commands that work. How do I think about AI in cybersecurity? What do you mean, how do I think about it? I think AI is good. I think it can be a clutch for people who are starting. But it can be useful to explain stuff, just like we used here. So I wanted better explanation. Okay, well, like, so why it's working. We don't know. We already know the. What am I doing? Oh my gosh, it's not even the length of our shellcode. We're trying to figure out just the length of just all possible characters from top to bottom, which is going to be 256 no matter what. Because it's just 256 is the maximum maximum amount you can get in a byte. So, like, what am I doing? I'm actually tweaking out. But anyways, it doesn't matter that the command doesn't work, but, like, still, fix your command sector box. Okay. Okay, so now they're doing that. Okay, fine. Alright, let me get this just in here. It's good for copy pasting. All possible bytes. Okay. Okay, let me just... There we go. Copy. It's not supposed to be shellcode. Okay. All charts. All charts. All characters. There we go. Put them on there. Good for copy paste. So now we're gonna put that in there. So we're gonna run, or let's go up here. So instead of this, it's gonna be minus minus 100 for, no, 255. So 10, whatever, this is fine, minus 256 for our chip 1 going. And so that's that, and then before that we put our shellcode in there. Not shellcode, it's just characters. Okay, that should be good. I didn't break Bofunk. Oopsies. Run it again. Alright. Break. break of vulnerable function. And then I guess view the stack. What up, Edwin? Okay, so we go to not the start. We want to start where a thing is. Here's our buffer shit, and then we start here after EIP. Characters are starting here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is gone. We should have 9, but instead we get this. So 0 is a bad byte. So then they remove 0 and run it again. Okay. Destack. Find the char list. What is replaced for how do I say this? And what is missing? The replacement is a bad byte. So in this case, 6 or 9 is missing. It's replaced by a null byte, so that should be removed. Okay, and then they just do that over and over and over again. Jax with another gifted sub. Thank you. Thank you, thank you. Much appreciated. Welcome in. We are doing a tier 0 module on Hack the Box Academy. We're doing Linux 32-bit buffer overflows. Thank you. It is the affiliate anniversary as well. Much appreciated. Okay, so they do that. Wait, they moved. Why did they remove 9? Oh, okay. So then they just do it after 8. 9 is okay. That's after doing it again. Okay, so we can just do this again if we want. We're gonna have to 2-0. You can't do that. Stop lying. Stop lying. Do this. So we remove 0 because that's a bad byte. And then we'll increase 1 here. Bam. And then I didn't break the funk again. Bam. Then dump the stack. And we see here we go. 1, 2, 3, 4, 5, 6, 7, 8. Wait, what? Wait, am I tweaking? I am tweaking. Nine is the bad byte. Wait, go back. Alright, so it's whatever's missing. So no byte's missing, so that's a bad byte. Remove that. 9's missing. That's a bad byte. And then when we get to here, A's missing. That's the bad byte. Which is what we have here. So in this case, it looks like 9's a good byte. Solving box after learning this? If we have time. Maybe. It's what before. Find what is missing. it's a bad byte. Okay. Okay. I think I get that. I think I get that. So here should be OA, but it's gone. So let's remove OA. Subtract or add one here. Then remove OA. One, two, three, four, five, six. OA's gone. Okay, so it's 9. That's the problem there. It's not easy for me to kind of understand which one's the bad byte and which one's not. 8. Okay, because they're both gone. Okay, that makes sense. That makes sense. That makes sense. We're good. We're good. That makes sense. I think we're good now. Where's... Did it break? Do we have FF? Okay, 6, 7, 8, 9, A, B, C, D, E, F. All the way up to FF. I think this is good. There's not an easier way to see if this is missing, though. I'm not a fan of this. No, because it doesn't show. Is there a way to see 0, 0? Here. So I think 2, 0 is a bad byte, because 2, 0 isn't showing up there. Okay. So here I think, so we have 0, 0. We have 9. We have A. We have, I think, 2, 0. Oh, gosh. Is that really it? Emacs 0, 0, enter. Scroll. Why does it remove it? Accept it. Control R. And 25. Where's 25? Okay, I'm just gonna go there. 2, 5. It's there. Okay, maybe that's because I have to remove 20 first. So if I do this again, 9 now remove 20. 20's gone. Oh, never mind. It's like, it's not 20, 20. It's because hex. It's like 2, 0. Add one more too. Probably doesn't matter if I add one more. Maybe it will. I'm gonna do it anyways. Make it good. Okay. Now we see 20's gone. 21, 22, 23, 24, 25, 26. 25's still good, I think. Is that it? Yeah, that was it. Okay. It wasn't 25. Oh, those are just common bad bytes. Okay, so 25 is also a common one. Alright. I'll put those in my notes. Common bad bytes. I am. Alright, so now I think we're good. All the bad bytes are gone. No more bad bytes. We're gonna have to remove those, though, in our shellcode. So dash dash bad shards. dash dash bad chars. How does it want it formatted? It just says chars, like, oh, here we go, example. Okay, I want it like that, cool. Remove bad chars to shellcode. So they're outputting that to a file, doesn't really matter. Let me just do that. Submit the size of the stack after overriding EIP as the answer. Depends on encoding and how the payload is being interpreted, but for string-based stuff, that list is pretty good. Good enough. First byte of our shellcode and match the bytes. The size of the stack space after overriding EIP. The size of the stack space. How do I get that? After overriding EIP. The stack space wouldn't change. I guess it would. What are these questions, dude? Why does it want that? Kind of irrelevant. Well, let's do it anyways. Let's take this. We're gonna get the size of it, which is 95. So we need to do minus 95. There's that. You do this. I'll put this in here. Gotta remove all this crap. New lines. There's gotta be a better way in Metasploit to format it just like this, you know? Or see the best way. You have to just do this. What's up? Okay. And then this should be 941. Okay, so now we just overwrit that with shellcode with no bad bytes. Is that the principal size? I think it is too. Using tmux. Yes, I am using tmux. Split terminal. Now if I just host a listener dash lvnp on 13337, and I didn't run this. Why didn't it work? Oh, it's because I did breakpoints. So I have to do C continue. No? Why did that not work? Anyways. Size of the stack. I didn't overwrite EIP with the address of shellcode. Oh, you're right. I just have this. What is this? F4 times. So we have to find where this is gonna be, and then point this to that. You're right. Not that. We're not there yet. As we're starting up. All right. So how do I? It's the size of the stack. How do I find this? This is just info proc mappings. Stack size. Okay, that's so stupid. I don't like. That's not even it. Like what? What? We've overwritten info registers. We've overwritten EIP, right? Or have we not? Oh, we haven't. I think I have to continue first. Yeah, we have to continue. We have to exploit it, and then we have to info registers. Now it's overwritten, and now we check size of stack, and now it's there as it's running. It's the same size. I didn't think it would change. Why the fuck is that wrong? It's fucking... It's because they have to SSH, isn't it? Is it? That's probably after... Yeah, I have to do this other thing first. So silly. It didn't change. I didn't think it would. This? Oh, that's the size. I was looking at end address. Oopsies, wrong one there. There we go. Wait till that's over. Recap. All right, chat answered the question. Had to be on the SSH session. Got the size of the stack by using info proc mappings, and that was after we ran it with this. So this is printing U 941 times to get right up to. Actually, it's better if I do this. Here we go. This is how we got that number. 941. Why do you 941? Oh, that's not. Yeah, that's on the side of the shell. So the shell's 94 bytes. So it should be minus 94. 95. Oh, but what? It should be minus 95. It should be that. I did it wrong then. Whatever. It should be this. Whatever. We're gonna get there. we have it formatted right. And now we just need a point. Let's go back here. This should be 945. That's what this should be. Alright, so that'll get us. Where did I get this? Minus. Oh, because I need to do minus the EIP as well. So I was right. Okay. Okay. So this is the whole thing. But we're subtracting for the EIP. And then we're subtracting the size of our shellcode to get right the offset to get right up to before EIP. And before the size of our shellcode. Then we put in our shellcode. And then we put in EIP. And now we're gonna Bro's no longer skid. What up, coder? And now in EIP, we're gonna put the we're gonna point it to the address of our shellcode, and then it should execute, and then we should get a shell. Possess degree embedded software development, OSP, pen testing, security research. That's hype. All right. Identification of return address. All right, we still control EIP. Now we need a memory address where our NOPs are located. The landing pad, as ChatGPT like to call it. Thank you, Midnight. W coder. Address must not contain any of the bad characters we've previously found. Oh, interesting. Why is that? The memory address can't contain. Oh, because the memory address is gonna be in our payload. That's why we can't have the memory address containing bad characters. So how do we get around that? That's interesting. Do we just have to get lucky and then modify NOP as much as until there's no bad characters? Here we now have to choose an address. Yeah. Yep. So here's NOP. We point EIP to where NOP is, lands on the landing pad, and then it goes across, executes our shellcode. There you go. After selecting memory address, we replace x66, which overwrites the EIP to tell it to jump to this address. The address is backwards. Entered backward. Oh, because it's fucking... What is that? Little Indian? Alright, but how do we find the memory address of our NOP? They just took this as an example. How'd they find this? Oh, they just dump stack and grab it. Yeah, okay. Examine stack. Yeah, okay. Oh, they're called Little Indian. Little Indian with the E. Alright. So here's our NOP. No, that's not NOP. Yes, this is NOP. No. What was our NOP? Did we add a NOP? I don't think we added a NOP, did we? No, we didn't add a NOP. So we'll put 90. 100 times. Okay, that's what they wanted. Okay. I'm just gonna do it here, do the math in here anyway, so it carries over. So it's 1040 minus EIP minus shellcode length, which is 95, and then minus our NOP, which we're adding now, which is gonna be 100. And then before shellcode, we'll add our NOP, and that should be good. Then we do one of these, dump stack. We find the address of NOP, which is 9 zeros. Should be 109 zeros. And I'm not seeing any of them. What? Let's continue. There we go. No. That doesn't look right. You thought it was Indian the whole time? No, it's Endian. Why don't I see it? This doesn't look right at all. Yeah, they got a bunch of 9 zeros there. Wait, they did a much bigger size. No, it's the same size as mine. The fuck? Why do they get that? Eh! Hold on. Where's mine? Did I type my command in wrong? Hold on. Print this that many times. Oh, looks good, dude. Plus this that many times. 100. Should be fine. Did I continue? I did. I did both. I did before I continued and after I continued. I think my breakpoint. I think I do. How do I? Yeah. How do I view my breakpoints? I continued, and then I dumped, and I still don't have. I still don't have it. 90. Yeah, it doesn't exist. How long have I grinded for OSCP? 200 flags. Probably about there. In total. Probably a little less, actually, when I took it, but... somewhere around there, probably. I don't know why it's not working. Info breakpoints. You can delete to get rid of all the breakpoints. Okay. Any BP? No. Nice. So let's just run this. Bada bing, bada boom. Pump stack. Oops. Where is it? Pump stack. It's not here. Like what? What up? Can I ask something? No. You can't ask anything. Yes, obviously you can ask something. Jeez, why is that not working? There's gotta be something wrong with my command. I don't see what's wrong though. It seems fine to me. Unless it's this that's breaking. Because this is the only thing I just added, but I don't know why that would break. That shouldn't break. That should be fine, right? Okay, well, fuck that. Go down here, minus, what was it? 100? 841. It doesn't matter. I have it like this. I have it like they... I have it as they do, but I don't know. I'll just put 841. It's the same. What? Am I tweaking? How much time do I... Can you or you put into learning cybersec? You learn daily or 2 to 3 days in a week? Answer, it depends. Depends. Like for example, there at the like in the past, I have gone months where I have studied every single day. Currently, it's not so much anymore. It's probably like, yeah, 2, 3, 4 times a week. And that's because a lot of my time is now, job hunting. So that takes a lot of time. No, it's not. Find command for find. Oh, find. Oh, it's 90. That's not an address. That's just times 100. What are you doing? What do you mean? What's GEF? It's like a module or plugin, whatever it's called, for GNU Debugger. I don't know, it's just, yeah, enhancement. Sure, you can call it that. Well, why is this fucking failing though? It should be fine. OX90 is not defined. Ah, fuck. It's gotta be in single quotes. There we go. Ah, darn it. There's my landing pad right there. There we go. All right, so landing pad starts here. So we have to add, I assume, add 2 to this. So if this is 48, this is 49, and then this is 40A. I want to say it's 40A, and then we're gonna have to do this on the target system, aren't we? Oh, there's no question for that. What are we doing? Oh, now we just, okay, we put that on the, on here. Put that as the IP. So we execute right there. So I think it's 4A. Because if this is 48, then this is 49, this is 40A. Or assume. So let's run this again. But instead of this, we have this. And it's reversed. So let me do this. X. X. Oops. Oh my gosh, I hate this. Okay, so it's like that, and then that's reversed. So F, just copy this, paste it in the front. Bam. And then copy this. Paste it in the front. That's reversed. I guess pipe it into rev. Actually, no, I couldn't because it's like, it's formatted like that. Whatever. Okay. And then we want A here instead of 8. And I think that should be good. Let's set up the listener. Please work. Oh my gosh. Here. Let's go. Hell yeah. That's hype. Oh. Yes, sir. Yes, sir. All right, find oh, let me just get this sample payload. All right. Find where find NOP by dumping stack. And memory address as EIP. Remember to convert to little endian. Like that. All right. And Bob's your uncle. We did it. Yeah, modifying public exploits, fine. Intentional errors. Huh. Funny. Mm-hmm. Have I tried Pwn Tools yet? No. Yeah, we know about some of these. What are canaries? Values written to the stack between buffer and control data to detect buffer overflows. In the case of a buffer overflow, the canary would be overwritten first, and that the operating system checks during runtime that the canary is present. Whoa, that's cool. Okay. Skills assessment. Oh shit. Here we go. Alright, I'll look into Pwn Tools. Should we do this assessment with Pwn Tools? Maybe. Maybe we look up a video on how to use Pwn Tools. And we use that. Enable SSH on a Linux machine during our pen test. On this machine, there is a program called Leave Message. The company pays a lot of attention to yada yada yada. After research, we found out the messages are stored there, which binary is owned by root user and suid set, meaning we can execute the binary as root, determine the program, and find out if it's vulnerable to stack-based buffer overflow. If you have found the vulnerability, then use it to read the file root flag.txt placed on the system as proof. Python script said the one line. No video, it's dead simple. Okay. What up, Tyler? Welcome. We're doing stack-based buffer overflows on 32-bit Linux. We just completed all of the modules. We got a reverse shell on just a sample binary. Now we're doing the skills assessment, and we're gonna try it using Pwn Tools, the Python library for binary exploitation. Have yet to take a look at it. Yeah, I actually that's when I first started taking look at them, because I think I didn't even know. I think I started learning buffer overflows. Like, I didn't know anything about OSCP. I just knew that OSCP was the goal, even when I started. So I was like, okay, what's something I should take a look at? And then I think I watched a video on OSCP, and it was like, it was outdated, and I didn't know they changed it. So it was like, okay, you need to know buffer overflows. And I think they actually removed that while I was still learning them, but it was a long ass time ago. But that was my first look at them. And now we're just doing a refresher. Camera blurry. Fuck. I hate when it does that. Thanks, chat. All right, we're back. What up, Ice? Thank you. Most security folks can't do memory shit, reverse engineering at all. That's why we're doing the stream. That's why we're doing it today. It's just a handy thing to know, right? Like, your web apps, your networks, you don't need to know a lot of low-level shit. But there's just circumstances that's gonna pop up in my career where it's like, okay, I should at least know the basics of reading assembly, basics of binary exploitation like buffer overflows and such. And who knows, maybe I'll pursue it in depth in the future. But this was fun popping the shell. I can't lie, this was fun. Seeing this was like kind of euphoric right here. All right. Done with that. Done with that. It's SSH. Back the box. Student. Right here. Oopsies. That's cool, pilfers. All right. I'm in. All right, here's our binary suid set. Let's actually exfiltrate this. You know what? Let's do that. Get this command here. So let's just copy this over with SCP. Home. I could probably do that, and then leave message here. Cool. All right, now we have that. Now we exfiltrated that. So now we can do. Now we can. I mean, we could decompile this. Fuck it. Let's just use GDB on this. There we go. Build functions. We have main, and we have a leave message function. Disassemble main. We see setting suid bit, and then it calls leave message. So disassemble leave message. Here's that. Kind of hard to read in assembly. We see string copy. There we go. There's our vulnerable function, probably. We also see fputs. I probably should have gotten the list of... Well, let's go back up here. There was a list of vulnerable C functions. Where was it? Here we go. These are all the vulnerable C. Let's just go up here. Let's go. A few vulnerable C functions. And they're not vulnerable by... They're not inherently vulnerable. It's just if you they can be vulnerably used, I guess. They're easy to misconfigure, I guess is the word. They're easy to make vulnerable. Go back to the assessment. Okay. Determine the file type of leave message binary. It's an elf binary. We know that. No? What the fuck? File leave message. It's an elf. The file type. Binary? Like, what do you want? Elf 32-bit? Is that what you want? What do you want as the answer? Oh, you wanted elf 32-bit. Okay. How many bytes in total must be sent before reaching EIP? All right, we'll get there. Let's figure out how to use Pwn Tools, chat. Pwn Tools is a CTF framework and exploit development library written in Python for rapid prototyping and development, intended to make exploit writing as simple as possible. That's what we like. What we like to hear. From Pwn import. All right, let's make a little thing. Exploit.py. All right, import Pwn. Probably gonna need to pip install it if I haven't. I may have installed. I don't know. Set context. Okay. Our arch is gonna be x64. How do I do that? I'm gonna need like a little bit of an intro here. Little bit of an intro. Is there like a wiki or something? Pwn Tools info. That would be a starting guide. Like that. Getting started. Pwn Tools documentation. Here we go. That's what I want. All right. We don't need to make a connection. We'll get there. What up, Morpho? Far as context. Okay, he's set as equals. Should that be 1 equals? Alright, context. What is word size? Alright, we want little endian. And we want arc arm 32-bit, so it's bits. Print context.args. Okay. Good to know. On arc. Yeah, we're in well, arc, right? Whatever. Let's just print. If that works, we'll roll. Like a little help menu. Ah! No module named Pwn. What? Oh, Pwn tools? Is that what I wanted? Fuck. What? My tweet? There we go. Arc. Is that gonna work? That's not what we want. That's just default. What do I... What are the all possible arcs? Oh, here we go. No. Doesn't help much. No, I think that's what we want. Why don't I use virtual environments? Sometimes I do, sometimes I don't. Depends. This just takes me an extra minute to set up. I think this is fine. Yo, what up, Dante? Indeed we are. Indeed we are. We've been working on binary exploitation, doing some buffer overflows today. I know. Pebble doesn't usually do this kind of stuff, but today, on Fridays we're doing... It's Freaky Friday, dude. We're doing some crazy shit on Fridays, so... That's what we're getting into. Gotta get out of the comfort zone. Sometimes. Later, pilfers. Okay, I don't like this wiki that much. Maybe that poem cools. Or file. It's an L32 but executable. Okay, that's fine. Yeah, that's fine. Okay, so we're good with that. We're good with that. So I think that's default, actually. I don't know. We'll keep it like that. Does it not tell me to set up context? Oh, we can actually just do that. That makes it easier. Wait, no. I just... Okay, never mind. That doesn't set everything else up. Murdoch, thanks for the follow. Let's just do this. Get what the name of it was. Leave message. Start print payload. That's what I want as well. That's what I want as well. But how do we like make payloads with this? Sending payload, writing. I guess writing payload. Payload equals B. I guess so. B in front of it makes it bytes times 64, and then P64 will. That's 64-bit. Thank you, Fedor. Skew with the follow. P4 makes it little endian. Okay. That's what we want. Alright, cool. So that makes it easy to reverse it. Oh, I don't want this is sweetness. Import sys. Buffer.write payload. Why can't I just print? Why can't I just do print and then say B so what do we want? I guess we'll use 90, or what do we use? I guess we'll use 90 for our offset. We'll print and break for annoying reasons. What do you mean? We'll see what happens. I want to see what you mean. Unless you want the pain. Why did standard out buffer right instead of just print? Let me see. Remove this. That looks fine to me. Alright, let's get started on this. This will make it easy for us. Alright, so first we just need like a million of them things. Let's go 1,000. Let's go 1,000. Oops. Let's go 1,000. Bam. Alright, we take this. Alright. So did I run that? Yeah, I did. Okay, so we're gonna run and Python let's see. Right. And then what do we want? What do we want? Info registers. 0 sec with the raid. Thank you very much. What were y'all working on? We're working on 32-bit binary exploitation on Linux. Hello, Rejava. Use the path of print. What do you mean the path of print? Hello, everyone. Hello from Spain. Thank you. So many follows. Appreciate it. I'm assuming Spanish speakers over there. Hopefully y'all understand a little bit of English. Because I don't know any Spanish. No registers. What? Why didn't this run? I didn't even see the functionality of it, really, but... Alright, I'll shout everyone out. Oh my gosh, so many. Murdoch, Thawne. Alright, I already got those guys. Wascom, Bendy, Gabo, Mind, in Java with the follow. Close Zobek. What am I doing? What am I doing? I'm figuring out. I have to put a breakpoint. Oh, you're right. What's it called? Called something. It was a call to, this is too many. What? It says main. It's called the leave message. Here we go. Break leave message. Now we run it with this. There we go. And now we can, functions, registers. It's not list. What is it? Info registers. Did that get overwritten? Did not get overwritten. Huh. Do I have to continue? No, that doesn't make sense. Does it need more? Wait, can I just do it through here? Can I just do this? Does that work? Hopefully that works. I might need this in single quotes. Didn't change it. Huh. What did we do before that changed? Why is it not getting overwritten? Panther with the follow. Does it need more than 1,000? Oh, actually might. You know what? It actually might need more than 1,000. I might be figuring out. We might need as much as 2,000. 10,000. Alright, that's not fixing it. Does Pwn Tools work in it should from here, because it should just be bringing a system command, right? That should work. Oh, wait, no, this is Python 2. That's not going to work. I just need to use Python 3 here. That's not going to work. That's why it's been failing the whole time. Let's keep it at 2,000. Let's do Python 3. Where's this? That should be fine. Still didn't fix it. This should run. Right? No. Yeah, that runs. Python. Okay. I just want to see the output of it before I run it. Okay. That makes it so much easier. Wait, but there's the B in front of it. We don't want this in front of it. You know what I mean? I got you. But we don't want this B in front of here. Yeah. We're gonna do this. We're gonna find the offset with the pattern. I just want to get this to overflow. Do I remove the B? I don't want the quotes around it. Is that why I have to use that That weird thing that you said to do. What was it? Is this prep for OCD? No. Okay. I'm trying to scroll up. Where was there? Yeah, the standard out thing. Instead of print. So I fixed it. Right buffer. Not buffer right. What am I doing? No, it was right earlier. It's buffered out right. What needs a string? Then print it. It works, but it doesn't print it. Supposed to be a string. Why ain't it printing it? Huh? Wait, maybe we shouldn't use NOP. So maybe we should use like something like 55 or something. Still. It's saying to write to a file. I don't want to do that. Bruh. Chat, I don't know about this whole... That's why. It's because it wasn't ASCII. I'm tweaking out. It's not an ASCII character. That's why I wasn't printing anything. It's not even an ASCII character. I was using 90, which isn't an ASCII character. That's funny. Alright. So that should be good. Where's that? Oh, there we go. Info registers has not been overwritten. Dog, what? 2000? Let's make it 10. It's not getting overwritten. Oh wait, no, I need to see the value of EIP. That's the thing, right? So, no, these are the values of EIP. That's not right. Maybe it's a specific functionality of the binary that's vulnerable. I mean, the skill assessment is going to be the same method as everything else. I didn't even try running the binary regularly and seeing its usage. That's probably something I should have done. File doesn't exist. Oh, it uses a file. File doesn't exist. Fuck you, it doesn't exist. It does exist. Echo 1 test. File doesn't exist. My ass. Don't help menu, of course. It might not be the first argument. What do you mean saying it's like multiple arguments? Or it's a... No, that wouldn't be it. I didn't read the... It was message.text. Is that what it... Hold up. Maybe I need to be in here. I probably should have read this a bit more. The messages are stored here. Okay, wait, hold up. There we go. Okay, it's gotta be run on here. So it has to be run on here. Damn. Well, that sucks. There we go. So we're gonna have to run GDB on here, aren't we? Unless we... Oh, we have to make a file called message.txt. That's what it's looking for. File doesn't exist. Message.txt. That's what it wants. It just wants me to touch this, and then... File exists. Still? Huh. Strange. Is it checking that it's owned by root? No. Really? Oh, it might have to be an SB absolute path. It may have to be, like, home, HTTP student, / message, do that. And then, might want that. There we go. That was it. I could have just done this as well. It probably shows it in plain text. Maybe not. Yeah, there it is. Whatever. I got it to work. Now we got it locally. Let's go back to GDB. Okay. Bam. Registers. Oh, I've run sudo. Ah, but now I don't get that. I don't have GEF here. Probably doesn't matter that much, does it? Fuck. I can change the permissions on this file. Let's go chmod 777 home student. That's your text. There we go. Now we're good. There we go. Now we go for EAP. Alright, that was kind of a hiccup. It's alright though, we got it to work. Alright, now let's find the offset. There you go, pattern, and take pattern, Our clipboard. We should have the cyclic binary now since I installed PwnTools. What do you mean the cyclic binary? Cyclic? Oh, that's just what that does? Alright, cool. Okay. Thank you. 100 into see. Why did I run it with this? It fails. It exits. Do I have to set a breakpoint? Probably. Wait, do it? No, I shouldn't have to set a breakpoint. Right? Or do I? Does it need more? There we go, I need more. So then what do I do after cyclic? How do I find the where the offset is? Like once I have the pattern. Registers. -L. Capital L. $260. Is that right? Okay, I think that should be right, right? Hopefully. I think it's right. That makes sense. 260. All right, we got our thingamajiggy. Cool. So with the size of the stack space after overriding EIP is answered. Info, memory, what was it? Proc, memory. What was it? Mappings. There we go. Ah, it's gotta be on the host. Fuck out. What? That's wrong? Wait, EIP didn't get overwritten. What? Oh, no, it did. What? I went too far? Oh. Oh, okay, it wants just EIP? Okay. So we go back to PwnTools. Let's go, so we want 1060. And then 4. Yeah. Oh, I have to B for it. Thank you for looking out, chat. We're good. Hold on. Yeah, let's start from the beginning. Mappings. What am I doing? Info. Rock mappings. We good now? Alright, we're good. Alright, now we have to do the rest. So, what are we working with? Working with getting some shellcode generated. No. Yeah, let's get a shell. Why not? Let's get a reverse shell. We want my IP address 10, 10, 15, 43 on port 443. Cool. Here's our shellcode to do so. So then, how big was that? 68 bytes. Okay. Minus 68. You'd structure it like this. What is this? Better not be some booty cheeks. Ah, I like that. I like that. Okay, okay. That's how I always see it. That's how I always see it. I'm just used to the way that they did in Hackbox. Set a variable as a string. So let's set it as here. I wish I was better at any of them. If I go here, no, I don't want the whole thing though. I want from here to the end. Inside. No. No. Let's look it up so I can get better. Let's select. New. Oh, I can just. Oh, right. Never mind. What is $? Oh, it's for visual. And then I actually supposed to go. Yeah, there we go. I got it. And yank. And then paste. There we go. Wait, how do I cut instead of yanking? Neo Vim cut. D. I can just delete it and then paste it because it copies the clipboard after I delete, I think. You think VI? That would copy everything in parentheses? Really? Oh, it does. Wow. Okay. Because, like, I've done that before with quotes, but I thought it had to be the same character. But that works even with parentheses. That's awesome. Thank you. Alright, so that's that. So we have 68 bytes for our, as we're going. We have 68 bytes for our payload, which you need to copy again. Oh, I could just... Can I do it in Python? I don't know. I don't know the best way to format this. It's fine. I can do it this way. There's that. Can I? Let's just check. It's for the future. It does. Awesome. Alright. That makes it a lot easier. It's alright, though. We shall keep it as is at the moment. Because I already have set up. So it's that. I need also -4 for, I think I need a -4. Do I need a -4? Payload plus buff. Yeah, if I want to do it that way, it's fine. Yeah. Or was it 64 -4? Because I think this was just up to EIP. Before reaching EIP. But I want to say it's this way. I want to say it's this way, but I don't know if that's right. Let's just send this and see if we get, if I get this as EIP, if I just get that. I didn't check that first. Should have done that. Wait, how am I gonna run this? That's not gonna print well. I'm gonna have to put the... That sucks. Do I need this here? I don't think I need Pwn tools for this specifically, right? Yeah, I don't even need Pwn tools for that. So I just need to put this, on the host. Wait. No, I don't even need to do it at the moment, because I can just run it here. I'm tweaking out. That work? It didn't work. But I think I do need it more. Do I? Need this? What? Pebble, I want to a tart. Start learning Python concepts for scripting and cybersecurity in general. Whatever I'm starting with. Recommend with capture the flags. I recommend track me and hack the box. That's where I started. That's what I recommend. Blaze with the follow. What's going on here? It's exiting normally. We don't want that. We want it to crash. Alright, I'm gonna see this just to make it crash. Just make sure it's working. There we go, that works. Oh, registers. Okay, EIP is too much. Was EIP... Hold on. I'm just gonna comment this out for a moment. -4. What did I set it as? Set it as 66. What is echo? I did that. 66. It's F. Should be F there. but it's not. It should be all Fs, but it's not. That's not right. It's supposed to be this. There we go. That's it. All right, we got it. All right, so now we have EIP working well. There are Python modules that hack the box and track me. I don't know about track. I don't know about track me. I don't use track me that much, but there are Python modules on Hack the Box Academy. Yeah, Hack the Box Academy certainly has Python modules. Thank you, class. All right, this is good. So let's subtract. How much was that? What's the size of this again? 68 bytes. So subtract 68. Alright, so now we have that. Cool, cool. This should be good. You need to get the address of... So is the address of our shellcode going to be... Yeah, is there address of shellcode going to be different on my host and their host? Let's add a NOP. Okay, so we're gonna need to figure that out on their host. All right, so let's. I think this is fine. Let's run this. But okay, I need to transfer this over to. I'm gonna have to transfer this exploit over to their host. If hopefully sys is installed. Vim exploit.py. Python 3 exploit.py. Looks like that worked. So now go back to GDB. On this. Info. Registers. Did I? Ah, I did. You're right. You're right. Fuck. Gotta end it. Bam. Go registers. Didn't work. Ah, I have null bytes. Fuck. Forgot about the fucking special shit. Oh, null bytes. Okay. Okay. All right. Let's just use our standard amount and see if that fixes it. I'm skipping steps just because it's not practice. I'm forgetting what I need. So let's try. Let's go back here and then dash bad chars. Let's just add all of these. These are pretty common. All right. All right, so now we're 95 bytes. We're good. We're good. Okay, that worked. Cool. All right, now we just need to find the address of it. And I think we're done. See the stack. It didn't view as much as we wanted. How do I increase this? 600? So we are right here. Thanks, home. So 741. Where we're at. Alright, so how do I convert this to little endian with Pwn tools? Oh, right, I want the beginning. You're right. You want the beginning. Right here. So 8, 9, DA, DB, DC, DE. DE. This is 4, right? DE, DE. B. What? Oh. Cool. That's the script. B32, that's 32-bit. Right. Shit. That ain't 32. There we go. That looks right. Just delete zeros. Right? Good, just deleted them. You're right. Bam! That should work. Alright? In theory, this will work. Moment of truth, chat. This would be freaking sweet. Run. Python 3 exploit.py. Didn't fucking work. No byte. Where's the no byte? I didn't get a no byte before, did I? No, I did. I didn't know byte. Bad chars. Where the fuck is my bad chars at? Gosh darn it. Am I gonna have to find some more bad chars? Are we gonna have to go through that hell? So bad chars is what? Based on the operating system? So is it gonna be different from mine? And is it based on the operating system? Is it gonna be different on mine than on the target? It's just so easier to do it locally, that's the thing. It's based on swing input. So it's not based on operating system. Gotcha. I can encode my shellcode. Well, encoding it, it's not gonna fix the core issue. It's just that we have bad characters. I mean, unless Shigata is gonna remove the bad characters, but it's not like our shellcode's getting caught by AV or anything. It's not like that. What up, Intrusion Truth? Welcome. Didn't that work? Why didn't that work? What works here? Why does it work here? It's the same code. When I do it here, it fails. What? All right, I guess I'll just do it. I'll just do it on the target. I'll just work with it on the target. I guess it's just easier that way. Do this. Oops. Let's go 700. This is actually not enough. 1,000. I don't know how much we need. Oh, I needed to do the the list thing. I needed to do this thing, didn't I? Okay. Fuck. I didn't need to leave GDB. Run. All right. What are we deleting? Versace is a smart fella. Definitely not a fart smeller. So A, which is a new line. Oops, missed it. We're gonna get rid of OD. We're gonna get rid of 09. Get rid of 20. Oh, a little bit of lag. And then 25. Huh? Put single quotes around this thing. There we go. No break. We need breakpoints, don't we? Do we need breakpoints? Househagen, you're smart. We're all smart. If you're watching Pebble Stream, you're a smart fella. No matter who you are. If you're watching Pebble Stream, you're a smart fella. Alright? Do I need to set a breakpoint at the thingy-majig to... I don't know. Can I still view the stack without this? No registers. Yeah, I'm gonna need to set a breakpoint, won't I? Breakpoint, what is it? Leave message? Yeah. Now we do this? And now we do this? Do I see my thingy? Kind of. No. I don't. Chat, where did I go wrong? Add not select. I like that idea. I like that idea. I like that idea. Oh, you know what? I didn't even get overflowed. Because I didn't have my shit at the start. That's why. What am I doing, bro? I'm such a goober. It would just be so much easier if I... What am I doing, bro? It'd be easier if I just kept it this way and just replaced the buffer overflow with the character table, whatever. I don't know why I'm doing this way. It's just I haven't done this a lot, so I suppose I'm out of practice. This. And I don't know how many characters we have now. Fuck. No, I do now, because I can count. Because I'm a freaking genius at shit. Except for when it's lagging. Okay, thank you. What do we want? We want this. We're doing a one-liner. Anyways, fine. So this. What's that? So instead of 95, this is it's 256 minus n, which is how many characters we removed. So it's 1, 2, 3, 4, 5, 6. 256 minus 6 is 250. And then let's just, to verify this is working, let's add our this. Alright, all is good. I should be able to remove the breakpoint now. Info breakpoints. How did I remove the breakpoint? What? Delete, not remove. Fuck me. There we go. We didn't get... EIP didn't work. Why didn't it work? Why didn't it work? One, two, three, four, six. Should be 256 minus 6. Which is 250. Do you know how AI overview in Google works? Yeah, I don't know. I don't fucking know. Why did this fail? Doesn't make sense. Thank you, Jador. I'm tweaking. What? Why is it failing? Gosh. What? There we go. But this works. What? Nothing's different. Oh my gosh. Alright, I should still be able to see what the knob slot is, in here, right? No. That didn't work at all. What? Why don't I even see what browser I'm using? This is Firefox. Bruce, what up? Thank you for the follow. After my offset, I don't see my fucking knob. Why? How am I doing? I'm doing well. Thank you for asking. Doing very well. Room buffer overflows. And I'm tweaking out. Should see my knob right here. Working, right? Let me just test this. Make sure it works. Yeah, that works. Later, Photology. No, it didn't work. This should not be. It's not interpreting it as bytes. Is it because Pwn Tools is not installed? Just a regular CS guy, so I get a little context what this is. Looks overwhelming to you. We kind of went through the entire module earlier. I can give you a little. Oh, it's hard to give you an overview without going really in depth here. All right. CPU architecture. A little bit like this. All right. So. Okay. So, I'll wait till the ads are over, and I'll recap buffer overflow. I think it's because I don't have Pwn Tools on here that's failing us. How do they do it with Python 2? Ads are over. It says there's 13 seconds left. I don't know how that works. Is print that times that. Maybe I just need to do with. Doesn't make sense what I have to do with Python 2, but I'll get this working. It was 31 seconds. I guess it's different for everyone. I don't know. Print. There we go. No. Yeah, that fixed it. Okay, it has to be in Python 2 on this host. Alright, fine. Anyways, I will explain it to you. So on low-level languages like C and C++, these are memory unsafe languages. Meaning at a very, very low level, the way computers work is it's all instructions in variables based on memory addresses. And so in a sample executable file, this one takes an input of a string, and then so just this one, it just takes a string of your user input and copies it into a piece of memory. If the space allocated for that string is smaller than what the user input actually puts in, then you can overflow the buffer, which is what it's called, a buffer overflow, for what should have been allocated for that string. And the example vulnerable function is string copy. So in this case, we're able to overflow where the buffer should be for the string and actually move into different places in the stack. So in this case, we're able to overwrite registers, CPU registers, such as EIP, which is the instruction pointer. So this says this is like the next instruction to execute when things are executed. This holds a memory address, so execute this at different memory addresses. So we can essentially set that to anything we want. So we could just make some malicious code and then set the instruction pointer to point to that code. Hopefully that makes a little bit of sense. You live in a house the same build of mine? That's funny. You have the same cube shelf? That's funny. Is considered medium level advanced topic? I don't know. It's a beginner topic in binary exploitation. It's very beginner in binary exploitation, but binary exploitation isn't like the easiest thing to start with. I mean, in cybersecurity, there's so many different concepts. How does it compare to hot tub overflow? It is the exact same thing as hot tub overflow. No, I wish, right? Alright. This should be working now. Run. Bam. There we go. Alright, now we got that to work. Alright. So now we can dump the stack. Bam. And there, okay, here we go. Here's a NOP sled. Alright, so this is our offset. Here's our NOP sled, and then here's our payload here. And we're trying to get rid of bad characters at the moment because the operating system doesn't like specific characters. So we're trying to find... Alright, 1, 2, we're just going by. We put in the payload of just all characters. So there will be a data leak. Worse, code execution. We're able to overwrite basically memory instructions. So we can execute our own machine code. So we just execute whatever we want. 2, 3, 4, 5, 6, 7, 8. Removed 9. Removed A, B, C. Did you remove D? Remove D. Yep. Where were we? D, E, F. 3, 4, 5, 6, 7, 8, 9, 10. A, B, C, D, E, F. 1, 22, 23, 24. Oh, that looks good. 3, 4, 5, 6, 7, 8, 9. Where's the bad characters here? We need to move this up a little bit. Anyways. Let's go 700. Zero. Huh. I don't see any bad characters. Zombagu, thanks for the follow. Right? This seems fine. I'm not seeing any bad characters here. So why did our shellcode fail? Maybe because we just weren't using Python 2. Maybe that was why. Maybe that was why. Ah, you bastard. Resources for buffer overflow. Pone College. I think maybe over the wire? I don't know. Hack the box. There's I don't know a lot of buffer. I don't use buffer overflow a lot. Maybe someone in chat. I remember there's another one. I forget the name of it. Just look some up, dude. I don't know. You probably can find more than I can. Than I know at the top of my head. There's a whole try hacking room, bunch of buffer overflows as well. How many bytes was this? Same as binary exploitation. It's a part of it. Yes, it is a type of binary exploitation. There's other types of binary exploitation that isn't just stack based heap up buffer overflow. This was 95 bytes. This should be 100. It's here. It should be 95. Okay. Oh, we gotta overwrite the. Where we gotta find our shit. I literally. Okay. All right, we're good. This is actually fine. This is good. We're almost done. Okay. Dump the stack again. We gotta find the memory address for our shellcode, and then we can put that as the IP, and then we'll execute it. Let's do. Is it the same? I already asked that. Here's our NOP. Okay, so we want D8, 9, DA, DB, D. What? I'm tweaking. 9A. B, C, D, E. D, E. I think we already had that for some reason. That didn't change. Okay. Strange. No, because we were working with this earlier. We were working with this. And it just failed. It didn't work. Why didn't this work? So odd. Oh, because we wanted to do it in Python 2. That's what we changed. Okay. Moment of truth. Damn, it didn't work. Null byte. Where's the null byte, dude? What? Oh, we didn't want DB. Yeah, we did want DB. No. What was it? Oh my gosh. This is DB. Do you want DB? Uh, 9A, B, C, D, E. We wanted E, not D. There. Well, why is it saying null byte? D, E. Whoops. D, E. Wait, why is there one in here? You're right. We removed that in the shellcode, did we not? Bad characters. I didn't put an X in front of it. Oh, I'm such a goober. There we go. Oh my gosh. We did all that for nothing. It's alright. Okay, this should be it. This is the final working shellcode. EIP should stay the same. I said deleting that. What? Huh? What the fuck is going on? I can't delete stuff. GDB's broken. Let me just paste that here. Just to copy it again. Oh my gosh. What? Delete. Paste this in here. Bam. Yes! Let's go! Oh my... Oh, we didn't run a sudo. Wait, why are we student? That should have been executed as root. Oh, we ran GDB with that. We ran GDB with it, not... Wait, but it's a pseudo binary. Or it's a suid binary. Why didn't that work? Why aren't we root? We ran it. It has a suid bit. Wait, is this my own shell? No, this is... This is on the host. What? This is a suid. Unless GDB doesn't run the actual binary and makes a copy of it, but no. Wait, what? Wait, then what am I gonna do if it's... Oh, let me get the working Payload. Just keep that, have that on hand so I don't lose it. This one. Why didn't that execute with it? Can I just do this? Or else I may not even need to use GDB. Just like that. Oops. And then listen. Or root. Bam! Yeah! Let's go! Hell yeah, dude. Buffer overflow for the win. Huge. What up, Stratocat? What up, Versace? Yeah, we did it! Freaking did it. So for some reason, Python 3 on the host wasn't printing, it wasn't printing, a couple things. It was weird. Python 3 wasn't printing, like, the raw hex. It was like printing the hex like ASCII, but it wasn't printing like raw hex. So I went down to Python 2 and I fixed it. And also my payload was wrong, because I typoed on the bad chars. So I was using this, and this had a null byte in it, wherever it is. somewhere in here. But yeah, that was funny. Here it is. Did I print or standard buffer print? Right. No, I used print. But it's weird because it works on my host. It works on my host, but it doesn't work on this host. It's alright though. We got it with Python too. It's fine. Alright, chat. Now what? Do we do a buffer overflow challenge on Hack the Box? Do we do a challenge? Can I search for like buffer overflow? It's gonna be under pwn, right? How do I know which one's buffer overflow? It's gotta be retired. They are all, but I need one with no protections. I haven't learned the protections yet. That's the... Alright, we're gonna have to do very easy. That's one of the lords. We'll get there one day. Only the gods know how to bypass protections. Well, jobs and subscribers security be owned by AI. Yup. Give up. It's a joke, by the way. Answer is no. Will I just pick one and hope? I mean, this one has a ton of solves. Questionnaire. Let's just download this. Downloads. Questionnaire. Yep. Check sec. All right, we're gonna read the source code. Oh, actually, no, because it's the compiler that has the protections, doesn't it? What is check sec? We have NX. What is NX? No! No! Damn it, Gar. Maticus Maximus, what's up? Juicy Delicious, thanks for follow. We're gonna end stream after I do this challenge. And I was gonna raid you right after, but you beat me to it. I haven't learned about bypassing NX. Well, maybe it's time to. Maybe it's time. Is it a bad time? No, it's fine. It's fine. NX means my stack isn't executable anymore. What the fuck? Well, then what do I do? Uh-oh. Buffer overflow. No execute. Later, Gar. Can't execute shellcode. So, I can't execute shellcode, but if I can still modify the pointer, then I can still point to any function I want. Or any place in memory I want to. So, depends on the challenge, I guess, right? Answer some questions to get the flag. So all we need is the answer of the questions. Doing buffer overflow, indeed we are. Alright, so... Oops. Test. Enter payload here. Boop. But I assume once we get the right one, it'll... That's test. Let me start the instant. What up, Angel? Alright. What is all this? It is a simple questionnaire. Get started with the basics. What is all this? Question number 1. Is this a 32-bit or 64-bit elf? I think this is 64-bit. Uh-oh. Example, lead-bit. Correct. What's the linking of the binary? The binary is dynamically linked. Wrong! Oh, it says dynamic, not dynamically. If I read the source code, I don't need to bypass an X at all. Or maybe I should have read that. Maybe I should have read the source code. It's called test. Why is it called test? It's like different. This is not the challenge, but template. To get the flag, answer the questions. There's no bug in the questionnaire. Alright, so I just have to execute GG function. That's it. I just have to execute the GG function. And then that'll cat flag.txt. So this will do my execution for me. I just have to set EIP to here. Alright, cool. Alright, so where's the overflow here? We set a buffer to 20 bytes. Or no, OX20, whatever that is. That's fucking 16 times 2? Is it? 32? Maybe? And let's use fgets. Remember, that was in our list of big no-nos. Gets. Oh, fgets isn't in there. All right, well we'll assume that's part of it. Standard in, I guess, this amount, so it has to be in between. I guess that's the most it can be. Is 100? Maybe. Okay, this is interesting. All right. Let's make a echo. Let's do this locally first. POC pwned into flag.txt. And then let's run GDB on test. Okay, well, all right, so I guess first we want to wait, how are we gonna do this remotely? Because again, with the offset, the offset's gonna change per operating system, right? So if I change the offset here, it's gonna be different remotely, and I can't debug the one remotely. Right? So how am I gonna know? I guess do I have to guess? Or can I just do it locally? And then the offset will be the same, hopefully. I don't know. We shall see. Let's go ahead and get, what's it called? Cyclic. Let's do 100 bytes. Actually, doesn't actually matter. do 200 bytes. And let's make a script for this. We don't even need phone. Maybe we might eventually. Okay, this. Actually, we just need to find. What we need to find? Yeah, the offset. That should be fine. That should be fine. Okay, so obviously there. Let's go. GDB. Test. Did I miss a lot? I don't know when you left. Maybe, maybe not. Run Python 3 exploit dot. Wait. It doesn't take it as an argument. Fuck. So I just have to copy paste it, I guess? Wait, I gotta copy paste it there? Just haven't. What do I want? I gotta find what EIP is. Oh, 64-bit. Gulp. We want RIP now? I think we want RIP. The power must be at least 4 bytes. What? We're working on bad characters along adding, subtracting bytes of shellcode, I guess. Better question, how far I've gone since that? Oh, I think we beat that. That was a skills assessment. I think we completed the skills assessment. So we're doing a challenge. We finished that. We're doing a different challenge now in Hack the Box called Questionnaire. Which is a new box, I guess. But I don't know why this this is the value of RIP, but Cyclic doesn't like it. So pattern must be at least 4 bytes. Alright, this is the context maybe? The 64-bit? Can it be 64? No. What did I just do cyclic for? I did. Wait, I did what? 200? I have to specify that here? Wait, what? Ruh-roh. Oh, it's no dash down, it's just 200. Yeah. The fuck? This is new because we haven't worked with 64-bit before. I don't know what changes here. Append double load at the beginning of offset because in 64-bit it's like that. Really? That's how it's gotta be? I have to add this to the start of my payload? A null byte? Wait, but... What do you mean? You mean here? Still didn't fix it. Oh, that definitely ain't it. What are these? 2, 3, 4. No, the offset. I'm assuming y'all meant there. Pattern contains characters not present in the alphabet. So maybe it didn't work? Let me see if I can just do, I can do this. On the 64-bit pattern doesn't get into RIP. The pattern doesn't get into RIP. But that's the X. We need to overwrite that because that's our BP, the base pointer. Let me just see where it gets fit into. Oh, fuck, I can't do that because of. It's fine. I have to copy paste it, don't I? Oops. Why did that fail? Maybe double quotes? Maybe. Where's RVP? There. That. Okay. So RBP does get overridden. Okay. So it needs to be RBP. So RBP is the base pointer. Is that similar to the instruction pointer? RBP. 64-bit stack base buffer overflow. Getting control of RIP. Okay, we first have to get control of RIP. Why is RIP not overflowed? The reason RIP's not overflowed is because it's considered a non-canonical memory address. What we put in is a 64-bit wide address. The current CPUs prevent applications and OSs from using 64-bit wide addresses. Instead, the highest memory address we can use are 48 wide addresses, or capped to this. This is done to prevent unnecessary complexity in memory address translations. So we have to find the RIP offset? Well, yeah, of course we do, but how? We could take control of RIP if the 64-bit wide return address, if it's invalid, the address value doesn't get RIP. Except, yeah, that's what I just read. Yeah, I got that. So you make the program crash and point to RIP, but now canonical. To find out how much garbage we need to send to the vulnerable program before we can place that onto the stack, so that we can take over RIP. In GDB PETA, let's create a pattern of 200 characters. Feed that to the vulnerable program. Is there the offset? Should be. Let's find the offset where we should place our preferred RIP value. What? Christy with the follow. They're just doing the first thing on the stack? Kind of confused. This variable would be popped from the stack and jumped into by the ret instruction. Okay, so it's just first thing on the stack is set to RIP. Okay. How do I see this in GEF and not PETA? PETA. PETA. The offset is the pattern where the RSP points to on the seg fault. Wait, really? So I can just jump to this address? And that's where it is? Or RSP? Wait, what is RSP? So this points to that address? The stack pointer. Okay. That makes sense. So this points to the start of the stack. And the start of the stack has our offset. Right. So we need to find... So we just need to dump a little bit of this. How do we dump this? I just want to read this on with GDB. Read. Memory. Read stack. Yeah, I mean. Do I set a breakpoint at this? No, that would make sense. It's not a thing. This is a good ChatGPT question. How to see stack at damn. Alright. Chill with all that. Don't need all that. /x 16x. x/16. Cannot access memory address. Why the fuck not? Why the fuck not? We did 2000. Why can't you access this memory address, brother? I think it's because we just run this and place the payload in there instead of running this crap. Here, bam. Now we do this. Actually, so what are we working with? Registers. So RSP, is that the same we had? It changed. Stack pointer. And it shows it up. RSP. It shows it up here. Okay, cool. So it's this. It's Kalama. It's Kalama. So we need to find where Kalama is. Actually. Okay. Should be Gal. Should be. I need to. Okay, so we need to find the pattern offset there. But I can't do that with PETA. That's not a memory address though. It only works with that. Right? Oh, it does work. Okay, 40. Awesome. Let's go. We're making progress. All right. So 40 is the offset, and then the next value has to be a valid memory address to get onto RIP. Gosh, like this is crazy. I'm learning so much. RIP under control. So then we do plus whatever we want, like this. So this will be a valid memory address. So yeah, I know, it doesn't matter. Because just whatever's right before it doesn't matter. All right, so we have this. So we want let's go x55 times, was it 40? Did we have? Yeah, it's 40. So that's our offset, and then payload. What is this? This is our memory address. So this is gonna be RIP. So then this should be in RIP if we run this. Hopefully. Wait, but I can't print these. How do I fix this? Because I can't print these out. String not bytes. What? How does that fail? They only concatenate strings, not bytes. What am I doing wrong here? How does that work? I see. Thank you for touching. Right. Then I get that problem, where it's just printing null bytes, which I don't want. And I can't copy null bytes into my fucking clipboard. First line of payload is a string. Yeah. That's the problem. That was the problem. R end up in. What up, Heb? What up, 3G? Oh, we're doing binary exploitation. So like when I run this, it prompts me to add a payload. I can't run it with a command line argument. There's a pop-up. So how do I get these null bytes in there? With GDB. Run greater than. Run less than. Okay, so that works, but No, that didn't work. Looking for this file, and again, it's printing out the null byte, so I have to use Python too, unless I have to use your funny thing. They should probably write down, which is importing sys, and then yeah, what it was. That was so a while ago. I need to write that down. It's gone. Versace, what was it? Thank you. I'm gonna write that down. Sys. Standard out. Buffer right. I should have gotten that. Actually, let me do this. Let me go cat back academy Linux buff. Wait. Okay, here we go. Let me just put this as an example. Oh, I always have this. Cool. Yeah, I know I could do that. I don't know how, but I could figure it out if I wanted to. Alright, so this line. I already got that. Does it work now? Yeah, it works now. Cool. Alright. Run this. Bada bing, bada boom. It now says no such file directory. That doesn't go in there. That doesn't work. Yeah, because what this does is basically it pipes the output of this into here. So it's like looking for a command called this, which doesn't exist, right? That's what this does. If I just run that, it's gonna give me that same error, or like a similar one. GDB prompt R. What is prompt R? What do you mean? Input prompt GDB. Feed input to program. Takes user input from standard in to GDB. R? Register for wrong, yeah. What do you mean it's the same thing as you do things but up by? Chat. B input prompts. Python input. No, I don't want the output. How do I do this? Input GDB with standard in program. Doesn't work. Do I need doubles? Wait, what? Double things? Wait, what? Oh shit, that worked. It's double thangs. This is wacky as hell. Cause what the fuck? Did that work? Please work. Oh, registers. We overwrote RIP. Let's fucking go! Alright, let me put that in. Alright, let me make a second for x64. X64. Alright. Gotta overwrite RIP. RIP needs to be a valid memory address. How do we even do this? Cat exploit. There we go. So, do, what was it? Cyclic. RSP will be the place at which, at which RIP starts. Sample to test for RIP value, RIP overwrite, I guess. All right. Let's just do. I'll put some GDB debugging. Let's go. Points modifying. Oh, let's go. Let's really get executing, examining. Input to standard in instead of args. Let me get that. Here we go. Bam. All right, good notes, good notes, good notes. All right, back to buffer overflows. We're on 64-bit crazy shit. What are we looking at? What are we looking at? Overwrote. All right, we're back here. This resource. Overriding RIP. RIP has been overwritten under our control. Is it the same as 32-bit from now on? We'd like the vulnerable program to spawn a shell. Yada yada. Okay, is it just the same as the rest now? I think so. I think it's the same as 32-bit. Right? So, all right, what was the vulnerability? Cat pest. Let's see. Right, we need to set RIP to wherever this GG function is. So, all right. So we go info functions. Let's do disass main. Call vuln. Disass vuln. Is it the fgets? The call to fgets, probably. That's probably where. Does that make sense? Gets the fucking file. So right into gets. I don't know if this is. No, this is the vuln function. We want GG. Could we just disass GG? There we go. That's the one we want. And then the call to system call. This is the one we want. Yeah, I got it. So we want to execute this memory address. So we want overwrite rip with this. Right? So instead of this, I can make this easy as well with home tools, right? So I can do T64 shaboing ya bang. Bada bing bada boom, Bob's your uncle. What's that look like? I don't know if that works. Right before the system call, it moves a value from racks to RDI. What do you think that's about? Use the first address in GG. Oh, okay, we want to do the entire GG function. I got you, right. It moves a value from racks to RDI. What's that about? Let's see. There's a value. All right, racks is. I don't know. Value from, what is racks? Any searching before the syscall. So I need to find where it calls GG. Or, oh, I just need this one. I need this one instead. What is racks? Register. Long size register. Is that this value, cat flag.txt? If you jump to... Oh, I was right, wasn't I? It's cat flag.txt. Let's go! Bro, I'm learning assembly. This is hype. Oh my gosh. Alright. Alright. Yeah. So, I want this one, right? I want to start here. Because I want to put... rip into here. Or whatever this is. This is cat flag.txt here, right? Or this is Lee. I don't know what that is. I've learned x86 assembly before. A little bit. It is important to learn assembly before learning binary exploitation. It helps, yes. Yes, otherwise you'll be learning while learning binary exploitation. Yeah. So where do I want to start? Can I just start up here? Can I just start at the top? Like, does this matter? Why don't I just start here? Or is that not how that works? Yeah, start at the top? Okay. I just want to make sure this looks right. Hold on. Python 3. Import phone. For all from phone? What am I doing? Phone. B64. This. B64 not defined. What is the fucking... What's this shit? Component for... Oh. Oh. Looks like that. That is not a... That's not right. What the fuck is that? Is that what it wants? How's it going? Going well. Is that what I want? Not sure. Oh, fuck it. I guess it's fine, maybe. That's what I have here. Let's see if that works. Bam. Exited normally. That doesn't... I don't think that's a good sign, is it? I don't think that's a good sign. That's not a good sign, is it? Exited normally. Fuck. Because we had it as this. Maybe I just change this. Why did Pwn Tools do that? Gian, thanks for the follow. Why did Pwn Tools do it like this funny shit? Okay, I'll just do it manually then. Oh, we also didn't want that. We wanted 176. That's what we wanted. Wrong anyways. See if that fixes it. Did I get any new certs? That's what you mean by how new. How new. Most likely not. Okay, that stopped. Catflag.txt. Did that fucking work? We hit GG. We did it. That did work. It didn't put in standard out. I don't think so. New ones after CPTS? No, not after CPTS. What, wait, so how do I... Did it work? Like, I mean, it obviously did it, like, I think. Try without GDB now? What do you mean without GDB? Will that work without GDB? Hold up. What is RSI here? RSI is this. I don't know if that's what we wanted, is it? Maybe I'd have to break before we're going to GG. BinSH. What the fuck? So how do we run that without like this? I just get a segmentation fault. Doesn't work. Nothing related to permissions. Felicity, what up? What are we doing? We're doing some binary exploitation. We're doing a challenge called questionnaire on Hack the Box. Was it something wrong with our... To break GG on this? So I don't know if that's right, because RSI isn't what we wanted now. Right? Or no, we want to break... I don't know when we want to break. This is complicated. Very complicated. Break GG, then single step. Right. We're here. We're good. We're good. I didn't see this. I was tripping the freak out. We're good. Okay. I was doing N instead of S. S is single step. Nope. That's not single step. What is single step? What? Step 1? Is that what I should have done? Oh, I have like 3 breakpoints. I didn't know they carry over. Whatever. That's 1. No. Step 1. Back. S. Yeah. Okay, that was right. So S. And then... it should have called it. We should have seen it and figured it out. We already ran that, Mirai. Or dot slash. I mean. I do have a flag to text in my directory. Right there, PSC owned for testing purposes, yeah. So we're here. This happens. Next. Or S step. I don't know why we're here now. I don't know what just happened. How do we go there? Like, shouldn't we just go down here now? Right? Oh, it says single stepping until exit from function GG. Which has no line number information. Why is it single stepping until exit? I didn't want you to do it until you exited. You bastard. Suppose it doesn't matter. It should still print and standard out, no? RIP E7F. How do we get that value? Of RIP plus E7F. I mean, it should be, yeah. And then Rex goes into RDI, and then we call the system command, and we good to go. P/X. No symbol tables loaded. $sign. Get this. Read the memory at that address. Oh, this is adding. What the fuck did I do? Print forwards /x/4x. Flag file, so it's suid. Sure. Well, I want it nasty. Well, the lab is just like it's just hosted on a port on a remote, but we're just testing it locally. We're trying to access the flag file. Where did my... Here we go. Yeah, that doesn't look like... That doesn't look like cat flag.txt. That's at RBP. Is that? But that's not... I'm so confused. RIP slightly off, so when does that offset calc is off. So where should I put RIP to? Is there any call to GG? I don't think there is any call to GG. So, I mean, we just did the first line in GG. Wouldn't that make sense? Disass GG. We do this first line in GG, right? That's what we have. You're lost. If you're lost, it's over. Here's our offset. This gets set to RIP. Oh. Which is this? The start of GG. Way to make it like maybe. What was the name? What was the name of what? I got it. I'm so smart, dude. Oh my gosh. I'm so smart. Jeez, bro. Just put me on the fucking equation group or something already. Jeez. Alright, I did here. I did it here. Because this is fine. puts into racks, racks RDI, calls it. I'm still not sure why the start didn't work. I don't know what this is, but I got it. We good to go. All right, now how do I put that through netcat? I think I'm gonna have to do the own tools fucking shit. Own tools. I don't know. What do we want? Because we need to like send this to the somewhere. Yeah, I had to figure what is this? What is this instruction? Remote, I'll check that out. Thank you, Oreo Bite. Eric's a valid target for indirect branches. Why does jumping to that fail though? What up, stupid? The first instruction in the function, which is exactly what we have. But why do we jump to that and it fails? It's only when we go to the instructions after it that it works. That's what I don't get. Thank you, fix it. What are we doing? We're doing, we started learning a little bit of binary exploitation. We're doing questionnaire on Hack the Box. Anyways, we got it to work. I just gotta send it now. But I'm still confused on why. Gotta look into that one. I haven't looked at it. No, this is 64-bit. This is 64-bit for Sachi. Next for the same to me. What do you do? ARM and stuff? Or AMD? No, ARM. Yeah, that's what I meant. ARM. What do you do? Yeah, mostly ARM. Cool, cool. All right. What was I doing now? Oh, yeah, figure out how to send that remotely. Remote. Remote server, P remote. Remote. Am I NASM compiling stuff? Don't even know what that means. Alright, now how do I send this to that? P.send payload? that work? I'll get to read it. Did work. Never receive all. They put that before or after? I'm not sure. Wait for the receive, then send the payload. Well, when will it stop receiving? It looks like it should be done receiving, but it's still waiting. Oh, until time. So I just want receive. I just want receive. Or rest. Not all. Well, that didn't fucking work either. Do I still want receive all? Receive until? Until when it... That's until a specific delimiter is encountered. Oh, we want print to receive. P to receive. We want this. Did I get the contents of flag.txt? I don't think I did. Do I need to do p receive again? After? What am I looking at? Where's the flag? I'm trying to send a payload to contain these guided questions. Does that matter? Or is it supposed to be like the end? Do I have to do this? Do I have to finish all these questions? It's not a container where the binary runs. What do you mean? Light year with the follow. It's the wrong socket. Eh. What? Oh, fucking fgets. What? Printf? Doesn't make sense. It should be fgets. I might have to finish the questions first. But oh, vol. That's the name of it? Alright, that's fucking stupid. The buffer size. Which function never gets called? GG. What's the name of the standard function that could trigger a buffer overflow? F gets. Oops. How many bytes? After how many bytes a segmentation fault occurs? $40. No. Specifically after how many? 100. Alright, you want me to do that? Really? Oh, fuck. Cat. Why is it not? Oh, 100 in Python. Maybe. Print 56. Really? 57? What? After how many bytes does segmentation fault occur? Do you really want to like manually do it? Don't worry. That was it. Or it could have been one less. What? Infinite? Let's go into W count. 41. What? It's 40. Okay. That's literally just okay, I'm just tweaking. That's literally our offset is 40. Yeah. Okay. What's the address of GG in hex? What's the address of GG? Well, this one depends on which address you're talking about. What do you mean the address of GG? Oh. Wait, couldn't we have... These two info functions. We could have just set the memory address to... We could just set the memory just to here, right? That's what we should have done. That's the real start of it, right? I think this is the real start. Or is that what we set to earlier? Is that what I did? Okay, then never mind. Huh, so strange. Fuck you. What? That's the box? We did all of that before these stupid questions and we were able to exploit ourselves. We literally we owned ourselves. And we didn't even get to own the box. Dude, I wanted to like pop shells. I wanted to like... Well, we weren't able to pop shells, but we were able to execute that function. At least get a flag. Damn, dude. That stinks. Stupid box. What up, Curtis? We're ending stream. Who's live right now, huh? Who's live? Nobody? Of course. No one's live. We'll read Martino. He's doing some music. Alright. Learned a lot. I learned a fucking ton today. Dude, this is... Alright, we're getting Freaky Fridays every Friday. We're learning some crazy shit, and it's getting good up in here. Curtis, I feel like you always join at the end. Most of the time. Anyways, we're going to be back on Fun Day Sunday. And... Raid. Martino. We'll be back on Fun Day Sunday. Only beginner boxes, only easy boxes. We're going in depth for all you new guys out here. Today was pretty complicated, but Sunday's the day to be there if you are new and want to learn some intro beginner topics. Anyways, I'll see y'all then. Thanks everyone for the biddies, follows, on those subs, raids as well, and everyone here just kicking it with your boy, learning something new. I'll see y'all. See y'all on Sunday, alright? Peace out, y'all.